right? Mic'd up, bricked up, mic'd up. Then we need YouTube chat. Have a little chat. YouTube. Refresh on that. Open that up. Then open up. I'm going to mute myself so I don't echo. Pop out chat. I can close that YouTube window. The number of video streams that I require Chrome to run at any given point in time is like way more than I need for streaming. What's up, Madam? Hey, you already showed up on that. Nice. Let's see. Got a bunch of data sheets open. Oh, lights. Lights toggle. There we go. I didn't sleep much last night. We're probably not going to do a long stream today. I do want to fix Dave's module, though. More is broken than we suspected. And day before yesterday, we traced it all out. But when stream's over today, I need to upload another video because I don't have one scheduled for tomorrow. And I've still got 120 some odd to put up. I had a total meltdown yesterday and didn't get anything done. So I didn't do my uploads. I don't know, I might miss a day. That's gonna kill my channel probably. It's awfully dark, yeah. Without lights are like the biggest asset when you're doing stuff with webcams. What was I gonna do? Oh, I was gonna reposition the fan. It is hot today. Hot. Hot. So I made a little bit of room over here. Well, that's a little dark. Let me brighten up this. This camera's designed to look at. I set this one because it's set to look at very, very brightly lit wall. So where's that camera? Properties. Your video. There we go. So I'm setting up the Elegoo goo printer in its own little house. That's Creality printer tent that doesn't quite fit my CR10S. It could. I could make it fit, but it kind of doesn't. So instead I put it on its side and put it under the desk so that I have a place for the disgusting resin printer that's down there on the floor. The expensive saw, I don't know what I'm going to do with that. And then my dual joystick setup is also on the ground over there. I don't know what I'll do. This is the aftermath of all that stuff getting out of there. I've got this big control panel that was supposed to be for beer brewing that I never got around to, and the payphone and all this other bullshit. I got to get this thing out of there. That's the brew controller. Move that back to storage. Finally took the plunge and bought a 3D printer, Prusa Mark IV. Comes with a huge kit of parts. That's good. Those kits of parts will help you out massively. Yeah, find like a tuning site so you can really get that thing tuned up and printing good. Because once you got that asset, it becomes indisposable in sort of the grand scheme of doing stuff. This place is a dump of garbage. I need a little bit more room, and I need to get old things out. I also need to process all of my diabetes supplies and get my fridge running and get my optical table not leaning up against the wall and all kinds of other shit. I really need to organize way back there too, because that's a bunch of project dump that needs to go away. We need to focus and organize, I think, is one thing that needs to happen in the near future. But I want to get Dave's module out of here first. I really am sick of having this thing. I'm really sick of not fixing this thing. That's cool though. That's really exciting, Pseudo. What are you gonna start printing with? What material are you using? That should be a good time no matter what. Like, I'm gonna print rubber. Bottom. Yeah, things rolling on. Projects rolling on, the whole queue. I still need to do a test print with resin I'm setting up that hood to be kind of a, you know, a smelly room. The carbon filters, I put the original carbon thing in there, so they'll probably do something. Hopefully this resin isn't too stinky stanky, but if it's anything like the nail resin that I have, then it will be stinky stanky. And also, I guess I have a funnel, and I can't leave it in there too long. And then, oh yeah, the other thing that I need is 2 or 3, I don't know how many I'm gonna do, Tupperware bins. And those bins I will use to wash the parts, basically wash all the excess resin off of the parts. And then when there's too much resin in the wash, you just put it outside, and then it kind of partially solidifies, and you can filter out the unused resin, or used resin at that point, but you can actually just throw it out. You don't have to like go to a chemical disposal place or whatever. I have a spool of tapoo, been exposed to air. Yeah, you can dry it out. I mean, it's kind of fun. You put your, depending on how low your oven goes. And I guess it's probably bad. Well, I don't know what TPU outgasses, if that's one of the ones where you like shouldn't like cook a roast in your oven after doing that. I don't know if there's many alternatives though. In order to like dry out filament, people use like ovens. But then you could also, I mean, I bought a filament dryer just because my 3D printer sits under a window. So there are times, and with certain filaments, that things just are too moist. And so I just throw it into the dryer. And apparently you can use that dryer as a feed. You could just feed out through the thing. I don't like doing that, but you can. Basic noob question. Oh, I'm all about those. Those make me look smart. And looking smart is half of the battle. It's most of the battle, actually. If I bought an oscilloscope, what adapter cables would you need to get a Eurorack 3.5mm cable to the scope input? I'm glad you asked, because I have exactly that. I went on Amazon and I bought a BNC. It's dynamite. BNC 2 a Tangle. It's BNC 2 3.5mm mono. That's all you need. 3.5mm mono, BNC. And obviously it depends on what your scope has, but typically your scope will have BNC cables. Cheap BNCs kind of suck. They're annoying. They're a fact of life though. But yeah, BNCs. You want a dry TPU for sure? Yeah. You got it. BNC 3.5mm mono, or BNC to 1/8 inch. Is it 1/8 or 1/4? It's 1/8. 1/4 is the big guy. 1/4 inch jack. Yeah, these are just off of Amazon. Looked around and I found I forget what the length is, but I think these are the only option. But I got 4 of these now, just because they're so good. Capable but cheap? Yeah, Rygol's definitely the place to go for that, and they're not sponsoring me in any way. Remember, if I am super overly positive about a product, that means that I have been secretly conscripted to sell it to you. If I literally say there's nothing negative I can say about this device, then somebody has bought me out. There are negatives to everything. Oh, we need a half an hour to boot this thing up. I don't know if the lower models of Rygols take so long to boot, but I know the previous generation takes way less time to boot. Sigilin also has good ones. I have never met a Rygol that I have not had to replace the fan in, though. Having your scope make a little buzzing noise is just illegal. It's horrible. Scopes should be silent. I know a lot of test equipment, it doesn't matter if they get good numbers. It doesn't matter if there's fan noise, but I'm running a media studio here. So noise is anathema. Really good time at the Star Wars Galaxy's Edge immersive experience. Galaxy's, oh, that's one of them Star Wars, Infinite Star Wars Forever, until we're all dead and in the ground Star Wars. I was always a Trek fan, but they've ruined that too. I don't mind me some Star Wars though. Oh, I see what you mean. I see what you mean. I see what you mean. Yeah. Infinite products. Welcome to a protracted experience where statistically you should like this. God, that Adobe stuff, can you believe? I guess you can believe because it's how everything is going these days. I felt like something just stung me. What the hell is that? Just a little nerve thing. Adobe, like aside from Microsoft Copilot taking screenshots of everything you do, Adobe, in their wondrous and overly corporate thinking, decided that it would be awesome if they had content moderation based on your usage of their product. And they all blanket this under AI. They say, well, we can see how you're using our product and then make it better. And it's like, well, you could also fuck off, because there's a lot of security issues with that, especially in creative media. There are NDAs. And even in like corporate stuff, there are NDAs. It's like utterly ridiculous that they would think that this would go over well. I don't imagine that, like, it's insane. It's just insanity. Yeah, and then they talk about content moderation like it's fucking 1984, and the thought police are gonna come and get you. We're gonna content moderate art. Ain't the future grand? It's amazing. I can't believe that they thought that would go over at all. Like, because you have, I mean, even beyond that, there's like, you know, I would imagine even for things that are like classified, there's a certain degree at which you want to open something in Photoshop. If I take it to my own experience, we had classified projects that we used image editing techniques in order to, you know, for instance, figure out where the circuit was going. And so you would be allowing Adobe Incorporated in to look at your classified stuff. Oh, but you have to opt out of it. You can just opt out of it. You can just opt out of it, and then we'll turn it back on during an update. You can just opt out of it. Just opt out. Every single time you use the program, it'll ask you if you wanna turn it on. That's the one that I hate now. YouTube did that with their tracking what you watch. EU must have bent their arm backwards and made them actually stop it, where your watch history influences what they recommend. And I'm sure it's not actually off. I'm sure there's still a history, but at least on the surface, it looks like they allow you to not have a viewing history on their front page. But every time you open that front page, it says, hey, you wanna turn on that watch history, and there's one button that if I press that button, I will never be faced with another button to press about it again, but it'll permanently turn it on. So it's this one-way street where I get a window every single time I disagree to be tracked. But if I agree to be tracked, into the background it goes. I like, that needs to be policed. that behavior, because there's a couple things like that do stuff like that, where every time you use it, it will prompt you saying, hey, this feature that makes up our front page, you can turn it on. Here's the button. It's right here. Here's the button. Just push that button. And it's like, no, like I'm not going to push the button. I might accidentally push the button though, in which case turning it off is, it's gone. You have to go into the settings. You have to go deep into the settings to turn it off. Microsoft has been doing this with a bunch of different settings on the OS side. Meanwhile, I have a copy of CS6. Yep, that's what I'm using too. Before they put internet in my software, exactly. Yeah, the CS6 is the version that I got from a buddy of mine whose company buys Adobe for Macintoshes, and the package happens to come with a Windows key. So he was like, yeah, you can use it. I don't know if I have that anymore, but maybe it's still somewhere. But it's like, yep, not updating it. I don't care if they add little features that make my life slightly easier. Publishing to YouTube is probably a lot easier on the modern software, but here we are. This kind of touches a bunch of stuff as to why I don't like open source stuff for the sake of right to repair. People will make forks without the crap. Why I like open source stuff for the sake of right to repair. Did I say don't? I think I changed the entire nature of your comment. Yeah, having open source stuff that can either delete the feature, or the devs just are too busy or too smart to put in the evil 1984, citizen monitor. It's nice. I don't know why all of the big techs are like, what if we monitor everything the user does? we got the newer versions of Windows hitting print screen on you every now and then. And it's a feature. They say it's a feature. Big brother bloatware. Yeah, big bloatware. It's utterly ridiculous. I guess it only works, the Copilot thing only works on ARM-based machines or something. But they're getting there. It's getting there. But yeah, I do not understand how, I don't know, what would you call it, deaf Adobe can be. They're like, stop pirating our software, please. And it's like, dude, the only reason that you became the de facto standard is because people pirate your software. People have been pirating that since they were kids. And that's how we all learned how to use Photoshop, which is not exactly, at least back then, it wasn't exactly a forgiving way of editing video and images. So, craziness. I still haven't printed anything on the printer. I have to put a new bed on it and then space out the Z-stop with washers because the bed that I'm going to use is a piece of steel. It's just a flexible piece of steel. And so instead of just having the base surface, because it's been all marred up, whoever had that printer before put it through a hard time. And the whole bed is replaceable. I mean, it's just a $40 thing. But if I put the big sticker on top of it, that'll sort of gloss over the damage that's been done to the bed, because then I'll have the flat plate of steel on top of that, and it should be pretty flat. I don't, maybe on a microscopic scale, it might not be as flat as it could be. But I think that'll just kind of like, brush the leaves over top of our shame and allow me to get some prints. I don't know. Fruity Loops Studio is the most pirated music software by accounts? Ha! They handle that differently. They said, buy one lifetime free update, and they've held to it. That's pretty cool. I see. So they put like modules and DLC out, and that's how they support themselves. But you can still buy a singular license to Fruity Loops Studio. That's pretty cool. Nice of them to do. Yeah, I mean, I would think they would do like a next version, and then that would be the one that like drive more than one lifetime purchase. Have they done? They probably done that. Go to like a new version, and the new version you'd have to then subscribe to for life or buy for life. This song's good. This one's a narrow escape. This is DJ Shadow in the background, so just so you know, I don't want to show. Showing the YouTube video, if it's something unique, gets me in trouble, apparently. You can show it right there like that. A Prodigy music video did that to me. Now that I'm free of using obscure music, because the YouTubers can't hear the music in the background, and the Twitch viewers will only hear it if they're watching live. So I can play whatever I want, but yeah, it doesn't live on. It's a scorcher today. I think it is going to storm a little later on, so we might have some lightning or something going on. The Northeast is in, crazy temperature mode. It's already brutal right now, and it's what? It's only June? I had to double check by counting the months in my head. People call me smart, but little do they know. We're going to try to get to the bottom of this VCO today. I'm going to try to, we'll replace the part. We need to desolder the one part and replace it. And we'll see if we can chase that signal all the way out to the outputs. I'm hoping we can. There's not much else to it. I don't know what else there is to it. We'll have to take a look, but just a series of transistors that could potentially be bad. and I wouldn't know how to replace them. I guess I could probably put like, well, depending on what they are, they're probably NPN, right? We'll have to take a look into it. You know, the worst thing that could possibly happen is that all of the transistors are dead, and the only things left are the transconductance amplifier, which is the voltage-controlled amp portion of the synthesizer, all of the transistors that make up the filter, and the transconductance, oh no, I just said that, and the output op amp. But the output op amp is easy, like I have tons of those, so I don't know. Yeah, that's what it is. That's what the whole thing is. The Acid Labs M303, which is a TB303. Trying to learn electronics more deeply. Any advice? Learning electronics more deeply. Usually the way that I've sort of branched out into analog electronics is just by throwing myself into some project and then getting deep into the project. In terms of learning deeper, it's been a long time since I started out, so it's hard for me to recommend. I had a buddy, Julian, who comes in here and plays music sometimes, was asking me about you know, one of his teenagers at work wanted to learn more about electronics and didn't know where to start. And I'm like, I don't either. It's been 30 years since I started in electronics. Everything is different now. From like I don't even know. Make Zine, the magazine, has a lot of good resources though, in terms of like understanding what's going on. Aside from that, I go on a project by project basis and learn in as I do. Blanket knowledge I went to college for it, so you know, I don't know. But we got a Discord, and there's more than just me on the Discord. They'll be able to answer those kinds of questions probably better. They are pretty common, and so I'm trying to get better at answering that question. I would like to get better at answering that question. DSP coder guy, that's kind of cool. It's good to give yourself a goal that might show you what the books might help. Yeah, and then it's like, I want to do this project, so I need this stuff in order to do this project. This project will help me learn about X, and then maybe you can get a little bit of motivation behind what you're doing. Because a lot of college for me was here is the math, here's the derivative of the equation that you're going to use, and here are problems that are on the fringe of what that equation lets you do. And you really need to get into it and do weird stuff about it. And I'm like, this is a terrible way to actually learn practical application of electrical engineering. It's awful. It gives you sort of a foundation, yeah, but it does it in a way that just is like designed to obfuscate it with stuff that you're never going to need. Yeah, I know how they derived that equation, but I'm not a mathematician. I don't need to be. I just need to be able to utilize these equations in order to perform a goal of getting a, you know, something, getting a project or an analysis or something like that. It's very strange the way that they do things. You played me, you going out of my mind. Sorry, for those on YouTube, you can't hear the music and I'm singing along to it. Not to mention there's probably a delay, so I'm probably like off. I can't imagine people who do music on stream. It's like, all the timings are so weird because like even the sync of my lips, you know, going into the whatever magical internet video thing I'm pumping this into through OBS. Even OBS will have a lag between audio and video because they're coming from two totally different things. Craziness. Yeah, I tried that before with I think when we were looking at some project that I wanted to do, and there were research papers detailing some of the stuff involved in it, but nothing like on the level where I could break it down into something that we could do, because it was all so high level and specific. You know, research, PhD and research papers and stuff, are they're laser focused on their topic. So you're like, oh, they put an amplifier in there, but it's like, what does that mean? did they do that with like some other thing, or is that a piece of electronics that I need, or what? So yeah. There were some cool things from research papers too that I really wanted to try out. What's up, Cat? I mean, one of them, the primary one, was something that I've actually already worked on, which was it's a non-invasive brain monitor that takes advantage of the fact that your brain divvies out the amount of blood that it uses. The brain always uses about the same amount of blood, but it divvies it out to regions of the brain by, with capillaries. So it'll open up the passageways to like the motor center of the brain if you're doing motor skill stuff. So with the final part of the brain that evolved, the prefrontal stuff, you can just go through the forehead and monitor what the brain doing. But you need specific frequencies of near-infrared light and that go through bones and stuff and bounce off of blood. And I wanted to put together an implementation of that, but it's tough. I'd have to source LEDs and things too. I believe they're probably still working on that though. They probably still have that technology somewhere. It was like AI. It was like a solution in search of a question. So they were applying it to all kinds of things. One of the things that they did apply it to that I thought was kind of funny was a lie detector, because lie detectors suck. They're not actually, people tend to think of a lie detector as like a specific problem solver, and it's not. And never let on to the fact that you know this, but the lie detector is designed to be the bad cop. When you have a good cop, bad cop relationship, you make the bad cop a robot that's reading stuff, and you can go, oh, that's weird. It's so strange. Anyway, I'm on your side here, and then they do the confidence man thing, and they get you to admit to stuff. Just casually admit to things that you wouldn't say if the lie detector was on you and active, or they get the lie detector to say, well, some weird's going on here. You want to elaborate on that? Because they're not admissible in court. They're total bogus, fakey confidence man things. And so this near-infrared brain scanning technology, one of the things they thought that it could be applied to, is looking at brain activity. So, in the context of if you lie, your brain is doing more work because you're thinking of the right answer at the same time as you're fabricating, I guess. It doesn't sound like this technology would do. It's like, well, there's more blood going to your brain now. So, but still, that was one of the applications that they named. I mean, the other one is just detecting hemorrhaging is another good use of that. But like fake brain sensing via just sensing something skin muscle related. Oh yeah. The ears, yeah. I'm gonna get my liquid here. I have a glass of seltzer. The main application, though, was just gathering data of the efficacy of the actual brain monitoring probe. And so what they would do is they'd have students come in and strap these things to their foreheads and do anagrams. And so there's in the performance of an anagram, or I think it was anagrams, I forget. It was little puzzles. And so you think really hard and you use your brain really hard on the language center and the front stuff, and you're figuring out what this thing is, and then boom, you get that eureka moment and you solve the puzzle. That happens very quickly, and supposedly your brain activity drops off sharply. And so they were trying to capture that. The thing is, you can't get a baseline for the brain, though. You can't stop activity in the brain, because that was part of calibrating the whole thing. You want to stop activity, or get the subject to like meditate or something like that, and try to pull the brain activity down a little bit so that you can calibrate your machinery, and then you can have them do stuff and you can see that activity. It was neat stuff, but very strange. Very strange. And it definitely didn't have a strong end game in mind. It was just, look at this thing. It can look at brains working. Look at that brain. Look how it do. I'm gonna get started in short order here. That's true. You can stop activity in the brain once. Oh, it was biomedical research is crazy. We had just these blocks that had blood in them. It was like this solid plastic block rather, a solid plastic block with it was like a milky white plastic, and supposedly it had like monkey blood in it or something like that. And you would put this thing on top of it, and then you would calibrate the inputs that way. So you had this block of blood, and you put your sensor on, and you go, okay, I'm calibrated, and I'm looking at blood. You put it on the subject, and then do the testing. I'm sure they've solved a lot of those minor calibration issues. When I worked on it, this is like in the 90s, early 2000s. It was more of an analog device. I'm sure now it's gone pretty well digital, and it probably calibrates itself properly and all that stuff. But back when I was familiar with the technology, it was literally light sensors with a built-in amplifier, and then an LED that would flash, and you would just take all of those analog signals back to a box where a data acquisition card would then take it into the computer. Nowadays, I could see that happening instantly digital, and you would just ping the device with a microcontroller and then send all that packet of data back. I'm sure there's much better, smaller ways to do everything. I run from bio anything. I throw a biography book on the table. The Adobe thing is just so weird. What is the repercussion for that? I don't think tools can some open source tools can hold at least a candle to Photoshop, but that whole environment is big corporations buy Photoshop. They buy the whole suite of Adobe products to offer to their employees and stuff. So what happens? Would significant people move away from it? I'm not sure. Yeah, it was the past couple days. I forget where exactly. There's a tweet that's the most, the one that I see everybody else talking about, but there's I don't know, a couple Reddit threads, and I saw it on Twitter. Yeah, I hear about Krita. It's decidedly not Photoshop. GIMP is the same way. GIMP is functional, albeit weird, and it's not Photoshop. Working in layers, yes, but some things are missing. Maybe they just won't add the feature. I don't know. Yeah, GIMP has its foibles. It is functional, though. It's better than nothing. It's better than paint.net. Soon. Not quite yet. I didn't really sleep last night. I have a spike in my brain, and I need to do my upload for the day today. 1 or 2. I'll be doing that into the evening. Yeah, GIMP is a very unfortunate name, and I really wish they didn't call it that. All I can do is just turn my brain off whenever I say it. Affinities has this kind of tools. I've never even heard of Affinity. Well, no, maybe I have. Maybe I have heard of Infinity. Actually, it's GNU, isn't it? GNU image manipulation program. I have a spike in my brain, yeah. Nah, that's to be. I have a very bad headache. Actually, don't have that bad of a headache. Software image manipulation program. That would do it. Cursed under. I can't now. I can't think on my toes today. All right, we should get started. I should work on circuits. Then I'll look smart. And remember, looking smart is very important. What's going on? Hi, welcome to Thursday. I'm feeling a little dumpy, so I want to do kind of a quick stream if I can. If this takes us a while, then it just simply will take us a while. I hope that this could be, I have to shave off my expectations with a whole bunch of adjectives, because Dave's VCO, voltage controlled oscillator, is really obnoxious. He had no expectations of me going into this, so it's not like I have the pressure of a client or anything bearing down on me. But a lot of this project that we're doing, this Fix Dave's Synth project, is to learn more about analog electronics and to kind of let me flex my muscles a little bit, while also moving me in a direction where I know more analog stuff. Analog stuff is insidious. It's all equations and everything is wibbly wobbly. Digital is nice and orderly and neat, and you can go, okay, that is what's wrong. Whereas with analog, you can go, well, okay, something weird is here and something weird is here. Does that mean everything's working, or does that mean something's broken? It is an absolute beast, because in order to fix this, we've had to get to know the TB303 intimately. We know every single atom's function inside of this system, sort of. We haven't gotten quite to the circuit analysis of the analog circuits where we're like, oh, this capacitor's here in order to prevent ringing. Like, we don't know that. But we do have a schematic for the TB303, and we don't have a schematic of the M303. The acidlabs.de created the M303 to be a direct descendant of the TB303. They have the same sound. That's really what Acid Labs brought to the table. They said we can use these chips that are available, and we can get the exact same sound if we do these special things. And it turns out they pretty much copied it. I mean, you know, that was expected, that it would be pretty much a one-to-one copy. If you're going to get the same sound, you might as well do the same things. There are slight differences, but they are not applicable yet. We have been trying to trace the sound from its inception to its output, and we're not getting any output. So as we roll through all these different functionalities, we've been able to identify where we can trace that signal, and it stops at one particular chip. Because Acid Labs wants to protect their work in this sort of bringing the 303 to the modern age, I don't even know if they're making this thing anymore. I don't think they are. But in order to protect all the work they did, they have decided to sand off the names of chips. And we took that kind of personally. I take that kind of personally, because that means that I can't repair my friend's musical gear, and they have to spend hundreds of dollars sending it out to somebody who knows better, which the person who knows better, absolutely let them fix it. But I don't know if Acid Lab supports this thing so much anymore. I'm all for them making money off of their hard effort. But I should know how to do this stuff too. So this has been a venture in educating myself and figuring out how this thing works. I'm not too hot to publish results about this, because, again, this is their hard work to put together this machine. There's a couple criticisms that I have of Acid Labs, apart from the sanding off of chip names, and it's that they did absolutely nothing. And when I mean absolutely nothing, I mean like absolutely nothing to prevent you from plugging this thing in wrong. A lot of these modules live and die by the power going into them, right? And if you put power in the wrong way, you can blow stuff up. Almost every single one of these modular synthesizer modules features two, not one, but two diodes. And diodes are a flow prevention device if used as one. They can be used for a bunch of other things too, but I mean, generally, if you hook a diode up backwards, it will not allow current to flow. And so you have what are called Schottky diodes, which are designed to allow current to flow without using up too much of it. They use up a little tiny bit of it in order to perform their function. So that's such an important requirement on the stuff I work on. They make us do backward insertion tests on everything. You can't just rely on the universe to invent a better idiot. You've got to be the better idiot and prevent the better idiot. And so I, even in my own first design, featured a connector with a keyway so that you can't plug it in backwards. But if you do still manage to plug it in backwards, because they will, these musicians will, they'll manage it, then I do also have the diodes on here to protect it. Yeah, it's an automotive requirement that you have to be able to plug in the device backwards to power, because car batteries used to take out entire car electronic suites. It was an unmitigated disaster if you plug the car in backwards. Nowadays, they're required to have that kind of protection so that if you do that, you don't break the entire car. You don't total a car by plugging the battery in wrong. Because the battery is just two posts. People manage to hook them up all kinds of ways. What's that? They put that rubbery stuff. Celastic or potting. It's called potting, P-O-T-T-I-N-G, when you pour an epoxy around a circuit. And that does two things. One, it keeps people from poking their filthy fingers into your device. Two, it actually bolsters all of your big components, so if it's in a vibration environment, they're not going to work themselves free and break and fail. Three, it makes your circuit totally waterproof because you've covered it in epoxy. Four, it makes anything that produces heat totally dangerous in there. But yeah, it's very annoying, and you got to like X-ray in order to see what's going on under that. So anyway, Acid Labs did not put any diodes on their circuit, and so they deserve this. They deserve this reverse engineering that I'm doing. We're going to fix this module. We're going to try replacing this chip. This chip was sanded off, and we have no idea what it was. But on further analysis of the circuit, taking a picture of the top and the bottom of the board, overlaying them in a non-Adobe photo manipulation program, and then activating and deactivating the layers that represent the top and the bottom, tracing it on other layers, we now have a layout. And because the TB303 is a known quantity and Roland is awesome, and they have these repair manuals that have a full schematic, we know we've got more pieces of the puzzle here. We basically know where Acid Labs started, and we know where they ended up. So now we need to figure out what they're trying to hide from us. Here, let me get rid of this overlay. Bonk. Yeah. So we have been able to get through some of the non-superficial areas. Now, things that we don't really need to look into is power. Power user interface. We don't need those things because this has been reinvented as a modular synthesizer module. If I was doing a full reverse engineering, I would start with power. Power is one of the first places because everything needs power in a circuit. And so it helps you identify what things are. It helps you identify functionality and all that other stuff. You start with power and you move your way through. We were at the point of moving our way through. We were able to identify both of these waves that are in this sort of repair manual, which is awesome. I love how they include this. So we know that these waves are being generated and they look somewhat like what we would expect. I don't know about this 12 volts and 5 volts. I don't know about the 8 volts and 5 volts. But either way, we traced them all the way back to a switch on the Acid Labs module where you switch between the two different waveforms. So I find it funny that they did exactly the same thing over here. They decided not to have some kind of a more advanced switching method. They just literally put a slide switch on it. And so that slide switch then goes back, and we were able to trace it all the way back to where it is supposedly going into, right here on this thing right here, comes down and into what is called a transistor ladder filter. You can either do a transistor ladder or you could do a diode ladder. The transistors are kind of supposed to be used a little bit like diodes, where you're just connecting them like that, and so just, yeah, whatever. But the whole point is this is a filter. This is the filter portion of the signal, and we're trying to get that waveform on the other side of all of these transistors, on the other side of the structure here. We don't see it. It goes into our mystery chip, and then that's it. And if you look here, and if you look closely, maybe you'll see our input signal comes in through here, goes through a resistor to keep it from current from running away, goes through a capacitor in order to kill any DC components in it, and then it immediately goes into transistors. We have experience from the other part of the circuit, from the part of the circuit that frequently fails. These things fail due to being plugged in wrong so often that apparently I don't know, one of the engineers there put out a document displaying what parts need to be replaced if it was powered wrong. We've done a little bit more to break the module. I plugged it into the front panel wrong, and I think I might have broken some things too. But we've traced our waveform all the way to all these transistors, and because of that documentation of things that break, we know that one of the pieces that breaks frequently up here in the voltage-controlled oscillator portion is a chip that contains 5 supermatched transistors. So we know that they are using a chip that has a bunch of transistors on it. Our thought is that down here, we have the same thing. We may have the same thing. All right, what's Chapman saying? You can ignore the TB303 digital memory and sequencer. Oh yeah, none of that's here. No, we're talking about the basic stuff because it's a modular synthesizer module. This is a voltage-controlled oscillator, voltage-controlled filter, and a voltage-controlled amplifier. Those are the 3 stages that we have. Everything else is gone. Those FCC IDs won't exactly give you that. Sometimes you get a block diagram from an FCC ID, but I don't like doing that. I don't like going to the FCC to find this information. We've had a pretty good time just straight up reverse engineering it. So at the time, Moog was still enforcing its transistor ladder filter patent. I didn't know that, and had succeeded in taking up ARP music on using it. So EMS used diode ladders, and so did Roland. Ah, I see. Yeah, no, those FCC patents are devoid of very large pieces of information often, and this is much more direct. I mean, Roland gave us a freaking schematic for the whole thing. It's great. Roland, I endless praise because they give you this very detailed design documentation in here. I mean, this isn't just the schematic. We have waveforms being highlighted in various stages. So this is an amazing document. It's really amazing. So yeah, anyway, we've been going through it, we've been getting through it, and our best guess is that they are using yet another one of those, and this is very sloppy, my notes are very sloppy, but they're using another one of these chips that has the 5 matched transistors in it, in the ladder filter. We know the ladder filter's right there, because I mean, you can freaking see the capacitors and the transistor parts, even though it's a non sequitur transistor part. We can see that structure of 2 legs of the transistor being shorted together, and there's a bunch of diodes in line. So it's a very easy to identify location. You can see, like, okay, so that's connected like that. That one's connected like that, and then below it there's a capacitor. Okay, yeah, that's definitely what's going on right here. That's a unique circuit structure. What threw us off, and this is part of reverse engineering, is, well, what is this chip? What does it do? How does it function? And so we start not with the base functionality of the chip. We start with, where is power coming into this thing? Where does power come into this chip in order for it to perform the functions it needs to perform? While there are thousands of chips that have this many pins in this arrangement, because SOIC is a standardization, it gets a little bit more unique when you have power and ground coming into particular pins. It can often tell you what chip you're using, not in its entirety, but if you are familiar with how electrical engineers, how circuit designers put together circuits, you'll see a lot of common parts, and maybe they'll substitute in a generic, like a weird specialty part. But like, you find that power and ground and you go, okay, well, I kind of know what's going on here. Well, for us, we traced power and ground around the entire board and did not find any power running to this chip, which again, that's a data point. And that tells us, hey, maybe since we're in an area of the circuit where there's about 11 million, okay, where's my stuff? Where did you go? Where there's about 11 million billion zillion transistors, not a whole lot of connections to power. There's one here, I think. Yeah, that would be power right there. One connection to power at the top of the transistor ladder, and then nothing else, just sporadic grounding on filters and stuff like that. There's a power right there. Perhaps this component is 5 transistors in an SOIC coat. So that's our best supposition for what's going on here. When we trace our signal, let's see, I think is that this layer? Yeah. Our wibbling waveform comes from, it's the VCO, the generation, on this trace here. So it comes down, goes over to a resistor and a capacitor, and then one pin of our IC. So just like in the schematic, just like in the simulations, just like in the schematic, we hit a resistor, a capacitor, and then a matched pair of transistors. That's what that circle around them is. It means that these two are matched, these two are matched, and these two are matched. Well, it doesn't look like they did 6 matched transistors. I think they found that they didn't need it or something, because we have 5 matched transistors. This is 6. So I don't know how. Maybe they just threw an external transistor like this at it. There's a couple of these. I hope these are okay. I hope I didn't blow any of those up. But let's replace this chip and see if we can further our waveform, because we're not finding the waveform outside of the connections in here. Like, we can trace it all the way over to this chip where it dies. So let's put a new chip in. I mean, I could also just take this one out and see what's present on all the other stuff, but music, DSP, and synths are kind of my personal catnip. The environments I like to use, Max MSP and Audulus, work a bit like digital circuitry. I see. So you're talking about in the digital. I use a lot of scopes with min, max, mean, present values on float numbers, point-to-point debug things with numeric. Oh, geez. Yeah. I'm just learning. I'm getting my legs with this analog stuff. I am an expert in electrical engineering stuff, but you fall out of practice with things, and analog is something that I know, but I'm still getting my sea legs here. And the way that I'm doing that is by trying to fix my buddy's synthesizer, and so in doing so, I am refamiliarizing myself with how all this stuff typically goes together. The Xper nodes? I don't know what those. Visually connected with graphical wires. I don't know anything about the digital music creation stuff. The reason that I got into modular synths is, first of all, that, you know, everybody says that I should anyway. It's one of those things where, like, it's like my personality and what I do and all that stuff. It's like people are surprised that I don't do stuff with music. And then Julian, who's my modular synthesizer, well, my music creator, he's just a friend of mine. He's not all of these labels. But no, he's a buddy who's been trying to get me to build him a synthesizer for 20 years. And then also, with my knowledge of how to solder and build circuits and do all that stuff, I love how in the modular synthesizer community, you can go on a website and just buy the circuit boards, and they don't give you any other information at all. They say, good luck, asshole, and you just buy the circuit boards and are on your own to build it, because I build stuff. I have tons of stuff for building things. So figure, why not do a little bit of analog bullshittery? And I knew this would be torture getting into it, and here we are getting tortured. Let's get this chip out of here. Let's get a new chip in and see if that fixes this thing. I've given you guys all of the logic behind why we're doing what we're doing. Now to do what we're doing. God, it is just a scorcher today, isn't it? So, which one are we doing? We're doing the chip that's right by the transistor ladder. There's that. And then there's this. Okay, good. What is that YouTuber? Mortis Klein does a really good diode ladder explanation of how and why a diode ladder functions and why it's the way it is. And I watched it, and none of the information stuck. Absolutely not a single piece of information stuck from that video. It was a lot of very deep level circuit stuff that I don't understand. In spite of being immersed in this stuff my whole life. Yeah, the analog stuff is there's a lot of things going on, and Moritz maybe is not the best person at explaining it. Maybe I could be better at explaining it if I knew what any of it was, but it's just one of those things. Where are my tweezers? Here they are. Here are my tweezers. So we're getting this one out of here. What I'll do is I'll put heat all around the area in order to get everything up to temperature so that we're not flexing the board weird and so that we don't suddenly hit it with a change in temperature. And then I will focus in on the pins until they all become molten. Now, this is a very important thing when I'm applying as much heat as I am. This thing is set to 500 degrees Celsius after all. 550? What is it set at? Hold on. Oh, it doesn't tell me until I lift the thing up. But when I lift the thing up, it'll go into a cool-off mode, and so it'll start making all this noise. So I'm going to wait to make noise. But this stuff right here, Heinbach. No, I have not. I should check that out. I will not remember by the time I'm done streaming today. We have many, many hours to go. That piece of information, that name, Heinbach, not only is it going to fly away in chat, but it has already left my brain. So if you want to recommend something, I'm absolutely all for it. It's a better place to go on Discord, on my Discord channel, to recommend it. And I'm sure people there can comment as well. I don't really have a music production channel. I have like a share a dumb song channel. What's up, RYG? How you doing? All right, so let's get to work. Let's do this. And then I'm running out of these Supermatch transistor chips. We've already replaced the one over here that again was also scratched off. I got to make sure that all of these pins are all simultaneously, I forgot to set up the microscope, are all simultaneously molten. Otherwise, I risk pulling the trace, pulling the pad off of the board, and that would be a disaster. The way to get around that, if you accidentally do loose a pad, because for instance, on this circuit board, these pads are the only adheration to that substrate, to the FR4 substrate. Some of them barely have a trace that has a solder mask over it. So what'll happen is if I overheat this board, if I overwork it or overheat it, the pad might come, the adhesion that the pad has to the fiberglass substrate will loose. It'll loosen. And so you can have a trace that's floating around, or you could have a trace just blatantly break off, in which case you may have to scrape and solder bridge or scrape and put a wire bodge to that pin. Makes music using old banana jack test equipment. Damn, that sounds kind of cool. Man, it makes me wish that I held on to a lot of that old crap that I used to have. I've gotten rid of a lot of electronics in my day, and I should not have. I should have just kept a whole bunch of bins of bullshit. I kept the greatest hits from those, but all this old lab equipment that I had access to. Because that stuff would be in fashion for like music making and stuff. That'd be really cool. So I can get in here and blast this thing directly with heat, but it's better if I slow cook everything. HP word generator? What? That's cool. Yeah, a lot of like old. I don't know about stuff existing within the audio range of frequencies, but a lot of the stuff I come across, like older test equipment and stuff, is operating at outside of the audio spectrum, which makes it not as useful. I gotta make sure that I'm deliberately applying heat to where I'm applying it, because I really don't want to damage this board. Another way to get rid of these SOICs is you can just bend up individual pins. You just heat up the individual pin and then you bend it up. But you got to be careful on the later pins because you're only operating on a singular pin. All right, there's the old chip out. We still don't know the identity of this thing, and we may never know. But we have a very good guess as to what it is. So I'm going to put this one in our pile of unidentified chips, or just pile of chips up here. And then I'm going to grab the one we do know, which is a 5-transistor super matched thingy-wingy. I need to make sure that pin 1 gets to pin 1. That's going to be the tough part, too. So among these chips that I have in this little baggie are the right one. Yeah, there's like test equipment is not totally focused on audio. But like back in the day, audio was prevalent then, so you would think. But most of the test equipment that I always run across, it's like just like low frequency RF and stuff. That is where everything is designed to operate. Because everybody was doing RF back in the day. So I'm using solder braid in order to flatten the pins down and, you know, clean them. And I got to be careful because if I apply too much heat to these pins or to these pads, sometimes they'll start moving. And this is where I usually discover they start moving because the solder braid needs to really kind of keep on these. If I accidentally move the solder braid and the solder has solidified, I can tug at the pad and almost, you know, and remove them in some cases. So you got to be careful to continually apply your heat when you're doing that. And now I guess we can clean it up before we move on. So I'm going to get a Q-tip, which are over here. Not supposed to clean your ears using Q-tips, but I do. All right, get a Q-tip and my dwindling supply of goof off. Oh no, it looks like I have goof off. I use goof off. Alcohol works, 99% alcohol works just fine. Goof off is just orange scented, and it's a little bit angrier than alcohol. I don't let it linger though. You shouldn't let it linger because it eats plastic. Yeah, those old HP function generators were like, they could make the best square wave you've ever seen. Oops, that is going to be a problem. Now, this desk protector is probably on its last legs. The mat that I use is it's a sort of a cut mitigating mat. It's not like a silicone work pad, but it's the right shade of gray that my cameras can tune in on. All right, so there's our new chip. Oh God, I melted some of the. There's a clean spot. There's supposed to be like a grid line there, but now this is a big clean spot where I dribbled orange flavored acetone. Darn it. All right, so let's get that in there. Let's put this away. Okay, so new chip, who dis? What chip are we putting in? What was the name of the chip that I had? I think I still have a page open for it. Whew, smell that goof off. TLS74, let's see. We're just looking up various things. This is the one that I ordered and that came in, which is why we're working on this again, the MC1410410 whatever. Here it is. So this is the LM3045. 3045, it's a transistor array, and these are very well matched transistors. 2 matched pairs of transistors. Why is there the 5th one? What's this? I guess those are matched. Those are matched. But why do we have that extra one? Strange. You got the Gamer's Nexus soldering mat. What are they doing? Yeah, there's what is it called? The Sisters with Transistors, or Sisters of Sister Transistors, something or other title, as a documentary that I think was fairly recent about the ladies of electronic music and splicing tape around in order to create music. I hear something beeping. There's like a faint beep on the wind. LM3046. Oh yeah, the 3046, 3045. Yeah, so this is the part. I got a bunch of these. You know, you order parts by the bushel. Bonk. I think it was Sisters with Transistors. I think that's what I'm remembering. Good documentary. Short. Could have been longer. Could have been longer. Okay. Where's pin 1? which one is pin 1? This is Pioneers. Oh, okay. So it's got pioneers in the name too. No, wait, no, it doesn't. I don't know. I'm trying to work. What direction is this thing facing? Well, pin 1 is very obviously noted on this one, I think. Boop, boop. Yeah. Pin 1, upper left. There's a little, you can see the little divot of the little bauble. So pin 1 is by the capacitor. And so, in order to solder in, geez, where was the S on that one? In order to solder in an SOIC, SOIC is one of the easiest things to solder in. I actually think surface mount is easier than through hole because you don't have to flip the board around and you don't have to juggle a bunch of stuff and your pin 1s and 10s are all in the right parts. What we do is we slide the part into place. I use this hand cam in the way that I do so that you can see how I am positioning my hands in order to be this dexterous with both hands in a microscope environment. So when we're doing electronics, we get a lot of comments of people saying that, you know, my hands are too shaky. And I know that there's all kinds of, you know, ways that hands shake. And there are ways that I don't even perceive that would make building electronics impossible. But most of the people commenting are just not positioning themselves properly. If you brace your hands on stuff, this is just like welding, your comfort is paramount because it's going to show in the work that you're doing. So if you're soldering something like this, sliding it into place is the way to do it. That braces it against the board and everything, and then I make sure that my wrists are touching something. And if I can't do that, I'll reach my pinky out and I'll put it up against something that'll stabilize it. All that stuff just keeps you from shaking, those minor muscle shakes. They keep them out of the equation. You can see here that I'm not that great at positioning these tweezers today. I'm a little bit shaky because of I only got like an hour of sleep. So yeah, we slide this thing into position and then I can solder the rest of the pins. And I'll probably do them individually, even though you can drag solder these. And if you're crazy, you know, if you want, you could continue to work in hot air and just put a bead of solder down these pads. You just put a line all the way down these pads with what is it, the liquid solder? Solder paste, there we go. You put a line of solder paste down these pads, and if you put the chip just loosely down on top of it, you could hit it with hot air, and then surface tension and flux is going to keep everything in line. It'll magically put itself on there. Yeah, resting your hand on the table does wonders. And also the vise lifts the board up a little bit so that I've got sort of a, yeah, anyway. You guys get what I'm saying. You're picking up what I'm putting down. All right, so let's get some solder down here. I gotta get the spools in a weird position. Everything's in a weird position because the desk is full of our test setup. I had a DJ Shadow song stuck in my head, and it's just like a one loop. I don't use a lot of liquid flux. I don't like cleaning it up. This is rosin core solder, so there is a little bit of flux that comes with this, but I don't overdo it. I'm not Louis Rossman. I don't throw everything into an ultrasonic cleaner when I'm done. I work with the circuit, and so I don't want it to be greasy. That stuff is gross. Probably doesn't do too many favors for your well-being as well. You saw at the end there what happened is not something that I typically explain. Once I got the chip to the point where I can see that all the pins are lined up, that doesn't account for parallax. I'm looking at this. I am looking at exactly what you guys are looking at right now. I am actually looking at a monitor that has an OBS window with this video image on it, right? It's about the size of a tablet, and it is about 2 feet from my face. So I'm seeing what you guys are seeing right now, which means I have no perception of depth here. There are some microscope setups that do give you perception of depth, but you know, we're not made of money. So anyway, I'm looking at this in exactly the way you are. So this chip could be sitting above where the pads are. So at the very end of what I was doing, if you caught it, it happened very quickly. But what I did, once I got this into alignment like that, I put the tweezers on top of the chip and I push down a little bit. And before I push down, or while I push down, I also hit the corner pin with the soldering iron to make sure that I'm not torquing off this this pad. But what that did is that allowed the chip to lay flat instead of being, you know, like this or some weird orientation. It's something that I practiced, so. Nah, I just don't want to even buy. I'm not even going to buy. I don't want to buy stuff. Does it look like I need flux? It doesn't. It shouldn't look like I need flux because I don't need flux. So the chip being lifted up can sometimes cause weird stuff with like the pins not soldering, or like you'll see solder flow onto the pin, and it's like, wait, why isn't it getting up onto the leg of the IC? Ugh, okay, hold on. I got this thinner solder because it makes doing this with the SOICs a little bit cleaner. But you still need to position yourself. You still need to position your hands so that they're comfortable. And so you can get the iron to the chip without melting something else. I hope this is the solution. Oop, that was too much. Oh well. Nah, I don't need flux. I don't like it. Where's the chip? There it is. Gotta make sure it's actually soldered in. Now, it could be that this magically fixes the entire board. I really hope it is. But it's possible that some of the other transistors are broken. Oh, come on. That just put solder on the top of the iron. This is the larger iron head that I'm using right now. I could probably use the smaller one to do this a little bit more elegantly. That's good enough. People say I make this stuff look easy, but that's because I give myself every advantage. I make it easy. That's why it looks easy, because it is. I'm a little bit more practiced in it. Now that chip is to the side a little bit. It's not perfectly centered, which could bother me, and I could take hot air in here and apply hot air, and then the chip would shift over a little bit, but I'm not gonna go through the trouble. It can be a little bit crooked. As long as all the pins are isolated and connected. Okay, so that's the LM3046M. In that section of the board, I guess we're back to testing. We need to put power into this thing and see if it doesn't heat up in ways that we didn't anticipate, and see if it actually will output audio now. We have traced that waveform all the way to that chip. We don't know what happens to it after that. Was the chip even broken? We still don't even know that. So in order to plug this board in, Acid Labs gave you absolutely no indicators on the bottom side of the board. And we know that they're capable of putting text and stuff at the bottom of their board. They really could have labeled a stripe pin on this. That would have been nice, because this follows the conventions of modular synthesizers, but it also has a special Acid Labs plug that allows you to daisy chain a bunch of their devices together. But who wants that? So anyway, their special power plug you're supposed to plug in so that the stripe is on this bottom pin right there. So you actually are plugging it 2 pins off from its center position. And this is documented all over the internet. There's no indicator as to how you're supposed to hook it up on the back of the circuit board itself. This would be a nice place to put like a label or a sticker or a board marking, or maybe just use a normal connector. I offered Dave to desolder this whole thing and put an actual just normal power connector on the back, but he didn't want to do that. Yeah, it's like this is hobbyist level stuff right here. You should not be doing this outside of hobbyist level stuff. You're getting into a place where musicians are going to interact with your electronics. This is completely unacceptable. A bare header that's totally unlabeled with no housing around it is not how your professional music equipment should be going together. And I say that as somebody who has had to repair their friends' stuff constantly, things that have all of the protections on them. I have seen on the healing bench here. We don't want to lean this up against the metal. Lean it up against the FAFO sign. All right. What do we think? Do we think this thing's going to function? I need to turn it on, turn on the power supply, and I need to get the power supply outputting the right voltages. The problem is this Agilent power supply will not let you adjust it without turning on the power. So I need to unhook the power in order to turn this thing on. Less questioning and more just I'm trying to get my rage out about it, because it really is just not, like, even I wouldn't do something like that. I don't understand why the Germans at Acid Lab DE thought, oh, but you are not supposed to plug it in wrong, so it is impossible. Like, I think you need the fart box back. I do. That's a Node-RED project. That's a Node-RED thing. We got to get the front end of the shop needs to go through Node-RED. What's up, FK Productions? How you doing? It's a friggin' humid mess out there today. I don't know if we've gotten rain yet. I haven't. My whole window to the outside world right now is that. So I don't know what's going on. Yeah, it's a nasty one. Oh, this is on. I thought this is like my scope where it takes a full minute to power up. Plus 25, we take up to 12. Oh, we can turn this off too before I burn myself on it. Minus 25, we take up to minus 12. And that's it. Power off. Plug this in properly. Stripe, bottom row, bottom row. I gotta make sure about that. Dave didn't want me to install power protection. I could do it all. I could put power protection on this thing. I could put a keyed connector. But no, he didn't want that. Okay, so I have a 20 hertz square wave. Let's turn this to a 1 hertz square wave. So that would be FT step. Oops, wait, no, that was the wrong one. How do I operate this thing? This thing was cheap. I could probably use a more professional function generator. I do have an HP one that somebody sent in, but it doesn't work. I'd have to repair it first. We can see how easily repairing stuff goes. This is stream number 500 of the simple repair of Dave's Acid Labs synthesizer. 1 hertz square wave. That is a very slow square wave indeed. Look at it go. Boop, 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 boop. Do we want it to go a little faster than that? Nah, let's just leave it as it is for now. We'll do rolling scope on this. And then I'll pull the scope up on screen so you guys don't have to be in the dark. Where is the scope? Thermals, spring arm, overlays. Let's collapse that. There. Oh, I saw it. Where'd it go? Damn it. Oh, there it is. Oh. There we are. Okay. Okay, so we've got that square wave going into both the gate in and the VCO control voltage, the VCO 1 volt per octave. So that's this one and this one. We're looking at our output, and we are also looking at the VCO output. So we should not only see the VCO output doing stuff, we should now probably see the overall output doing stuff, assuming that our waveform is getting through the filter as it should. There may still be broken stuff in the circuit, but let's just see what we get. Power on. We get nothing. Good day to you, sir. Oh no, there's our waveform. It's coming down from outer space. So that's on this trace. Is that, wait, is that one output? No, that's our VCO. That's this one. So we see nothing on our output, but we do see a varying frequency from the oscillator. So we know the oscillator works, but we don't have any confirmation of any other piece of this functioning. Double check, pull this one, make sure we get noise. We get plenty of noise. Burp, 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 burp. Audio check, burp, 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 burp. And then on our output, we get nothing. Good day to you, sir. What about if I take the gate in, out? Nope. I got a little blip. All right, I think we're back to hunting. Just seeing if we get anything from twirling the knobs. Turn it to gate, nothing happens. Turn it to voltage controlled amplifier, nothing happens. It should be quiet, loud, quiet, loud. We are giving it a trigger. That's what's going in here. Yeah, we're seeing output from the VCO. So that's output from the VCO. This is our inducing signal. This is our gate and also our octave signal. The encoding just went weird. This is our gate and octave. I'm putting it into two places on the synthesizer. And so in gate mode or in amplifier mode, we should either see it going, you know, loud, quiet, loud, quiet, loud, quiet, or we should see that 10 volt or whatever. That's not 10 volt, but whatever. This should be enough to trigger the gate. So we should be seeing it gating based on that. So yeah, it's still busted. It's made a busted. So we got to continue to probe around and see where things are going here. We don't have a ton of access to stuff on the board, but we can poke around back here. I don't have these two separated out, so all I can do is get vias and stuff. And that's what this is for. So this will be our probe, and that's the blue channel. And so as we look at stuff on here, we can actually see... Well, hold on, let's verify that this thing works at all. Huh, I can actually hear that. Something is vibrating enough that I can actually hear it. It might be something inside the power supply because it appears to be coming from my right side. I can hear a very faint dee-dee-dee-dee. That's pretty funny. It's probably coming from somewhere inside the power supply, but that's weird. I wonder what I'm actually hearing. Or if it's just my brain doing it. I don't know. This can be a very quiet shop. Okay, so where are we picking up on this signal? That's just that, and then that layer not using. This one is where we're doing our signal, and that one was just an additional note. So this is where we started, where I got the signal at this horizontal via here, and then we chased it to the chip itself where we didn't see anything happening. So there was no signal on this right here, this little jump like that. So if we go from the center and we go down, we should see this little lower layer jaunt that we can then test. So we go from what we know. Oh, here, I can tilt the whole thing up like this. There we go. Okay, so we are here, and if we move over, we can see I have harassed the solder mask on that one a little bit. Can I turn on the scope in this camera? That would be very useful. I saw it. There it is. So yeah, now I can poke in right to the ear. And we just get a solid signal out of that. That's very strange because that shouldn't have a solid signal on it. That's where our stuff is coming in. Assuming it goes up and around on that capacitor, and assuming that that capacitor isn't connected to, maybe it is connected to positive and it's doing some kind of filtering. There aren't a lot of vias around here. I mean, I can check some of the ones over here and see if we can see our signal anywhere, but it doesn't appear as if it's getting to these later stages. Let's see what we're up against in terms of these later stages, and I can try to figure out where our signal comes in. We can get an idea of where to test to see if it's making it outside of the filter. And it could be one of the external transistors that's giving us troubles, but I mean, according to what I'm seeing, because again, if we go just just away from that area and we test over here on the horizontal jump, we'll be able to, let's just verify and get our signal. So if we go just a little bit off of that over here, ooh, that section of the board's kind of warm. Huh. So we're going over here and we should see just a direct horizontal, well, in this case, it'll look, yeah, here we go, just like that. And then I should see, oh yeah, but it's inverted. Okay, yeah. Somebody inverted the controls. So we're actually going this way, and there it is. There's our horizontal jump. So right here, I should see the waveform, and there it is. So there I see the square wave. It's a very dirty square wave. There's something else wrong with this, but for now we'll just deal with it like this. So we got our very dirty square wave that matches what we're tracing around the board. So that would mean that that section is fine, but then we move over to that capacitor, and the only other access we have to the other side of the board there is here. And when we get here, it does not do nothing. It's just flat. So maybe I'm not on a trace that connects to the waveform. How is the rest of this thing structured? So we have, here, let's get rid of the notes on this layer. Well, or I could just hide the layer. We're not seeing a waveform here. It's funny, I could definitely hear a ringing, and there's nothing in here that would create audio. The speakers aren't on, they're off. It's so weird that I can hear in the high-pitched noises that exist in the shop. I hear the waveform coming out of something. There's probably like a coil or something that's sitting on the audio, and it's like shaking and making a little bit of noise. Yeah, it's like everything that I'm looking at points to it going through here, through this resistor, through this capacitor, with plus in the direction that the, oh, well, let's check on that. On the TB303. Well, that's the opposite direction of that the capacitor's in, unless it's a capacitor that goes to like something else. But like our audio path comes through here and it hits the plus side of the capacitor, which is not what I'm observing here. The plus side of the capacitor is the opposite direction. This would be coming in through here. So maybe would it be going anywhere else after it gets to this? What does that look like? If this one goes up, like what is happening here? It goes under that, the plastic there, and then where does it go? Could it be going out up here, or should it be, I don't think it would be looping around. What's going on the underside of the board? There's one via there. These aren't amazingly lined up, by the way, the two images. They're off by a little bit. So there's a via like here. That might go this way. But then why would this do that? Yeah, that wouldn't make any sense. You would just put the resistor like over here if you were doing that. Huh. I'm not going to pull the capacitor. I don't think I need to do that. We could just ohm stuff out around it. Power down and then ohm stuff out. Now I did remove all the ICs. We do know what's underneath all of the ICs. That was just something that is just a stupid thing that we could do that would help clear it up. You don't necessarily have to pull the ICs to know what's going on underneath them, but we did just because it was something to do. And it sort of answered some of our questions. So I assumed, yeah, it looks like I didn't trace it out underneath here. So I assumed that this might be going horizontal in this direction and going down there, but we don't really know what's going on here. So I don't know if these are necessarily connected. This capacitor could be connected to this trace I'm going to pull the cap. Why not? We'll pull the cap and we'll see if that's what's happening. We'll see what's going on underneath. And that'll just help us figure out where everything's going. I'm annoyed that that didn't fix it. All right, I got to be careful because I'm using the flat connector in order to put this thing in the vise. I have to make sure that I don't power up my power supply and destroy the synthesizer again. I'll just pull the 3 cables over here and put them back when we're done. Just in case I bump the power supply and turn it on and blow up this thing again. This thing will not die. Synthesizer, that may mean that the other chip that we pulled is just fine because we're not seeing any difference in its function. Oh, I hate it when that happens. I hate it when that happens. We get all the best theories in the world going and we go, yes, definitely, that's definitely what's wrong. And then it turns out not to be what the problem was. Oh, that just gets me. That just gets my goat. I don't have a goat. So one way that I could do this is by point testing. I could point-to-point test to see who goes where. And I think that's probably the better way to do this, is to just take the multimeter out and just probe. So I'm going to take the multimeter out. I'm going to put it in ohms, not beeper mode. Beeper mode is useless. It will lie to you. Beeper mode is only good for diode testing. Or if you can't see the output of the multimeter. But there's so much more going on the circuit when you're trying to test for continuity, where if you have it on ohms, it will actually give you information. Like if I'm on sort of an unknown pathway and I test like this and I get 70 ohms, I'm not actually getting 120K. I should be getting 120K. I go over here. Well, there I get 0.4. So why aren't we getting 120K? There it is. It's a little cleaner. But yeah, you can tell like, oh, there's a resistor there. So yeah, now we know that this is definitely connected to this part of the capacitor. It's funny that it does that, because then that means the capacitor's backwards? I guess it's okay. And then this, because we know what's under the board, we know that this connects here. If I test from, where is that one? This pin, I should get to here. There it is. Okay. All right. So the way that I have it in the drawing, or sorry, in the image manipulation program, the way I have it here is the way that it is connected. It's just like, what's happening with that? Oh yeah, that one goes to a VIA, I guess. So that's the one, the customer that goes to this. So that goes up there. Okay. So everything we've put down on paper is correct, which means that our signal is coming in here, going through the capacitor, and on the other side of the capacitor, it hits this via, where it dies. And it shouldn't be dead. We've measured the capacitor. We got 1 microfarad. I was saying about DSP software a favor earlier. Oh, is that the debug monitoring of the wires between the program expressions is much like what you're doing in the multimeter. Yeah, there's commonality in a lot of this different stuff. A lot of the process doesn't change no matter what you're working on. It's mostly logic. It's let me eliminate all of these things that I don't know and make sure that what I expect to happen is happening. So that's what we're trying to kind of narrow down here, is where's the soonest that I can see the signal's not working. I wish I could test it on the other side of the capacitor. I can't get into the circuit board while it's operating. But we tested it on this pin, and this one pin has nothing going on. Why is that? Well, we've got some kind of a thing going on over here with the 5.2 volt power supply. The one thing about GNU image manipulation is I'm using the center pin to move this thing around. But when I let go of the wheel, sometimes it scrolls up and down. And when it does that, the screen jumps. It's very annoying. Yeah, that's true. I could solder just a tiny little wire on there. And I do have wire. I mean, like, we tested that to be 1 microfarad, so the cap isn't broken. It's definitely, this thing worked before. If I do solder a line on there, I mean, it's just as well, because I could just test it here. And we know it's here. We see nothing here. We just see a flat line here. So something else is influencing this branch of the circuit. That's a dot of solder. This thing is not actually, that's not actually there. That's not a thing. That fell off. 2.2K, 1K, and then we go to our 5.2 volt supply, which is coming from all the way up here. So if I put a probe here, and I put a probe on this 1K, I should see low ohms. So if I go from, let's see, where are we? Here's 5.2 volts. And then I go to this 1K right here. Ohms. Okay. So that's good. And I test the other side, I should see 1K. Sorry, 100 ohms. It's 1000. Don't let that fool you. That doesn't mean 1K. 1000 written on a resistor means 100 with 0 zeros at the last digit. So then if I go through this, it'll be 2.3K. 2.297. Close enough. All that's good. Could these caps be going bad? Let me visually inspect these caps. These caps, how can I reach them? They look okay. Like, there's no sign of damage to the circuit board, which is why I'm wondering, like, what the heck is happening? We replaced the chip, so all those transistors should be fine. We get, I believe we can measure we measured the 5.2 volts of the power supply, so that should be okay. In terms of bad capacitors, first of all, I mean, these are too new to have gone bad. I think these are 2013, 2014, 1014, yeah. These are 2014 capacitors, so they're not capacitor plug capacitors, and they are sort of the nicer surface mount ones. None of them show any signs of damage. It's possible that they could be bad, but at least our input capacitor, we measured at exactly the number of farads that it has on the tin. So yeah, the thing is, that's what we're in the middle of doing. That's what I'm doing. We trace our signal all the way into this capacitor. On the other side of it, and so I've got to look at what all it hits and see what happens here, because it's not like we won't be able to see the signal at all those nodes, because at that entire node, everything has just gone to a flatline voltage. So everything here, well, that's just one trace over to the 2.2K. And this is just like, it looks like it's just an elaborate pull-up. What does that represent in this circuit itself? Hold on. So we're coming in here, and we've got a 2.2K. This one goes to a capacitor and ground, which we don't have on this branch. That's not there. It does have this weirdo junction here. These circuits are very strange, these ladder circuits. I'm familiar-ish with one from a Hajiwo circuit, and I don't know what all the parts of it do. It seems to work in mysterious and wondrous ways. And I watched the Moritz Klein video on the design of a ladder filter, and I didn't retain any of it. I've watched that video 2 times, and it's just, it kind of like cascades in terms of the functionality, and things just get like weirder and weirder and weirder. So I don't really know what things should look like inside of this. Where is this coming out? That's a frequency adjustment. Where's like there's the cutoff adjustment. Resonance, envelope, decay. Volume is all the way down there, but that's on a different, see, there's the mixer where we're taking all of our stuff out. Voltage controlled filter. Well, what's the block diagram. I'm looking. Here's the block diagram. So voltage controlled oscillator into voltage controlled filter into voltage controlled amplifier. So that's our progression. We go oscillator, filter, amplifier. And so we have lost the signal as soon as it gets into the filter. Like as soon as it gets into the filter. The very moment. Because we can see it on the switch. We can see it on the switch and we can observe it going into this first 220 kilo ohm resistor. We see it all the way up to there. Anything after that is gone. And we've checked continuity on that resistor. We know that it is connected properly. No traces are bad in that area. Where does it come out of this and go into the amplifier? Well, there's the VCA. The input to the amplifier would be over here. Pins 2 and 3, it's just taking in a comparison. Where's the signal coming in? Oh, maybe, yeah, right here where it's summed up. So it's summed and then it's output over here. So our our input is here, coming from TP6 essentially. Oh, and that's where the chart is. Okay. So yeah, where they're showing you this 50K resonance. Okay, so if it's going to the resonance control in some way, we can see it on the output of the filter at resonance control. Because over here, C14, and then down and out to the amplifier, and then VR4, which is a 50K for resonance. That's where the output from the filter comes out. So all things considered, I could find where that output is, and we could test that. Resonance is this one. Well, there's a dual in the other one. We got tune, VCF mod, that's filter mod, then resonance. So this would be where it's coming from, or going out to. And there would be 2 connections. That's weird. How's that working? Well, the wiper is not the output, it's the one on the end, and then the other end of it goes to ground, which is not what any of them are doing. They're all going to unique places. Wait a second. Are they doing resonance in a different way? Oh, jeez. Ooh, I got a side cramp. All right, well, if I'm getting this data, then I'm marking it down. Well, I didn't take pictures of this, so each of these cascades is a 1-pole 60 decibel low-pass filter integrator. As they cascade, the phase cancellation. See, none of that's language. None of that means anything. None of that means anything. Those are just made-up words. All right, so I'm just tracing this out in my head to see where these are located, and it looks like it's not exactly doing what I thought it would be, because in our schematic, this control, the one that resonance, which, you know, they both have resonance, but the resonance knob connects to ground on the TB303. On this one, all 3 of these are going to another layer of the board. So all 3 of them are going somewhere. Actually, where is this one going? It goes down over to the accent control? That doesn't make any sense. It does, though. It goes over to accent control. And then accent control goes to the header, which could go to that 5-volt source or something like that. Maybe they're using like a virtual ground. But that would mean that, at least on some of these pickups, we should be able to see our waveform. So if I plug this back in to power it up, I'm going to make sure we do this every time. I mean, make, as opposed to just copy, Because if I'm copying it, I don't need to give a shit what's going on. I just copy it and then have one of my own. But if I want to actually adjust and tune and be able to make one of these just conceptually, yeah, I probably need to know what that stuff is all doing. Oop, that's not the way it goes. That's why we turn the output off, kids. Because yet again, being the German design that this thing is, there's a pitfall of being able to plug the front panel in backwards. And so if your holes don't match up, then you've plugged it in upside down. Which is, what a way to live. Okay, all right. So now I can power us back up, and we'll be right back where we were with this thing kind of wibbling away and not outputting properly. Oh, that was a hot dog burp. Ow. Man. You know, you put a little bit of jalapeno hot sauce on a hot dog with a little bit of corn. Did I put ketchup? No, I didn't put ketchup on that one. Make kind of a little bit of a taco dog, and it becomes sulfuric acid in your stomach. Where did my probe go? What have you done with my probe? Where did you hide it? I will find you. I will get my probe. Oh, it's right there. Okay. This thing is still connected? Yeah, to ground. Okay, so on, where is this? Resonance. We should have a resonance cascade here. Oh yeah, you guys can't see anything. Hold on. Scope on. This is getting a little bit out of control, this whole test setup. Although there was very positive reception to Tuesday's probing around for signals. So, oh yeah, this is AC noise. So this is that hum that you hear when you put your finger onto a like an audio cable. What's up, Bovinet? How you doing? Is anybody talking over there in YouTube? No, I don't see nothing happening in YouTube. YouTube's a very quiet place. Okay, so over here we've got resonance, right? So we know that the oscillator of the circuit is functioning. We know that's functioning because we can see the output coming from... Am I upside down? Wait a minute. This way. Yeah. This is the VCO output. We can see that outputting right now. So if I go to the resonance control... Oh, I was looking at the wrong control. That's what it was. So resonance is actually this big mother hubbard right here. So on this, we should see a waveform somewhere. But instead, I'm just getting a solid line. That one is ground, I believe. No, not ground. So when adjusting, no, it just goes to 5 volts. All right. So yeah, this is the output of the filter that we're looking at right now, and it's not doing... There's something that's adjusting its level as I go up and down with the resonance. There, nothing's happening. Okay. If you say get an 18 decibel octave slope out of it, you'd still have to use 4 stages, but you tap out of the 3rd. I can't process that right now. I don't know what that means. I can't process that right now. So my issue is that it is the weirdness of the square wave. Is that sort of causing the other problems to happen later in the circuit? We're in parts unknown here because we don't know, like the typical things that go wrong when you plug this thing in backwards went wrong. We fixed them. They're probably still fixed. It's just that there's further damage to the board. And so I have to figure out whether or not that further damage, you know, what I need to replace in order to mitigate that further damage. Like maybe I can adjust these controls and kind of make that square wave a little nicer, Or maybe the non-niceness is intentional. It doesn't look like the waveforms in the documentation, though. I don't know. I can't even get to this adjustment with this like it is. So, question is, do I get those IDC cables in here and try to make this work a little bit more open so that I can actually get to the stuff that I want to mess with? And to do that, got these. They were literally sitting right over there. So I put pin headers in these, and I need to get them to go to these. That shouldn't be too big of an ask. So this goes on like this. So lower one there, upper one here, and I need to make sure that they actually properly connect and don't connect backwards or some facsimile thereof. So if I plug this one in like this, and I note my pin 1 location, pin 1 is, it's marked with an arrow on the outside of the cable, so that's here. So pin 1 is there. So when this plugs into it, pin 1 here, pin 1 needs to be here. So look at this way, pin 1 can't be there unless I reverse the cable. How do I do that? Okay, wait a minute. Something, brain, hello? Pin 1 can't happen there. I need to plug in on the other side. Power's not still on. That's the frequency generator. Don't you question me. Don't you ever question me. Don't question. I know what I'm doing. I don't. So wait, why isn't this working out? Hold on a minute. So I guess this can't plug in like that unless magically I reversed it just by nature of the way that these things work. Unless I plug in on the opposite side of the board. So if I plugged it in on the opposite side of the board, then I could get it to work out. Is there something else that I could do? Cheap viewers, finally. Let me make them a moderator. Man. They make any money off of that? I know Twitch probably doesn't really police them all that much. Yeah, I want to separate these two from one another. I could do it with 1 billion jumpers. I could just yumper my way out of this, but I was hoping that I could use IDC cables, but the problem is the flipping of the pins. If I put this in the opposite way, no matter how I put this in, pin 1 won't flip around. I can't get the opposite side because they're done in like, they're done like, you know, they're like that. So if I flip the cable around, that doesn't change how the IDCs or the displacers are getting in there. The hovercrafts are going by right now, so there's going to be a bit of background noise potentially to my voice. I mean, if I had 10,000 jumpers, I guess I could do it with that, but that's a really annoying way to do it. Or if I, let me think about this. If I put a pin flipper like adapter, can I make something like that? I probably could. Do I have something like that? Wait a second. All kinds of weird hookup stuff. Have I like ever made something like that? I'm standing up because my butt hurts. My butt hurts. I've been sitting down for too long. I mean, okay, so I go through all this effort and I make a flipper and plug it all in, assuming it all still works. What does that get me? It doesn't get me all that much new. I mean, it would allow me to probe the board more effectively. I could solder headers onto the other side. And then it would completely expose this so that I can work on it here. That's so weird that the flat cable thing doesn't line up properly. The pin 1 ends up being on the other side of the header because one of these goes to the bottom and the other the top, I guess. If they both went to the top side of the board, then they would line up properly. Very strange. Now, to solder a new header onto this one, I don't know if I like that. I could desolder the whole thing and then put it on backwards. No, I'm not going to do. I don't want to do that. That's so much effort. It's just very frustrating that I can't plug this thing in properly. Yeah. Okay. All right. All right. So we'll continue to work on it the way we have been. So, all right, we've no mods on. I got them. I think, right? There's not anything else going on. You might be super delayed if you just got to the part where I banned that person. Oh, if your chat, yeah, chat's lagging behind or something. I don't see our audio signal anywhere in there. Does that necessarily mean that the filter's broken? I could get... Do I have anything that can create an external audio? I mean, other than this would be the only other one. And we could put that into... That's what we need to do next. Okay, I figured it out. I need to test to see whether or not this filter is working at all. And in order to do that, I need to put an external signal into that filter. So I need audio. Now, we've already got a lot of stuff on the bench. If I hook up another modular power supply module, just the VCO that we made, and I put this into the input, we can see if we can see it coming out of the filter. And we can verify if the filter is working or not, and that'll help us narrow in on what's still broken on this board. Or it'll just leave us in the dark, like, you know, like we already are. I think like 3/4 of this, 2/3 of this thing don't work, so I don't got much to lose. Let's hook up another module power. So I need a cable. Get these out of the way. Now, where did my other mod cables go? Oh, here's one. Here's one that I was using. Perfect. 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 Okay, so let's get this one hooked up in a cascade. I'll just move that one over to here. That one's still ground for our scope reference. And then the stripe is minus. Stripe to stripe. What is unplugging over here? What's going on? Oh, that's stripe to stripe, middle connector to middle connector. And then plus 12 on the opposite side to plus 12. There's that. So now I can hook up. Oh no, this is the wrong plug. Son of a bitch. Damn it. Okay, hold on. Oh, you know what? I can do this the opposite way. I can go from down here. There we go. Oh, that'll do. You'd think I would have come up with some tools to more easily plug in this modular synthesizer stuff by now. You would be wrong. What's making clicking noises? It's weird. Hearing all these weird clicking noises. All right, so this one down here is minus. Minus. This one is plus. This one is ground. Ground and plus. Now my VCO has the proper diodes on it, so if I screw this up, I should not blow everything up. Always a chance, but shouldn't. So there, and then power everybody on. And now I can't see it, but it should be outputting. So if I take, which was our output monitor? That's this one over here. Take this. See, it cuts off when I unplug. I plug it into the output. There's our audio signal. And those are audio waves. I guess, is that other signal invalid? Should it be a faster oscillation, or is it just expressing a very low note? If I take our control signal and I put that in, was that the control signal? Should be. Of course, mine hasn't been tuned yet either, so... looks like it's not. Oh, there we go. That's... Wait, what the hell's going on there? Oh boy, what is this? Well, it definitely is changing as things go by. Okay, well, whatever. We get a signal. Why would I kick the function generator up to 100? That's not... No. We're using the function generator to control essentially a knob. Oh, I don't need this result there. Get out of the way. And then... Why? I definitely hit 4. I definitely hit channel 4. That's what I want to scale. Oh, wait, 4 isn't... No, 4 is the wrong one. That's why. I'm actually inputting to channel 3 right now. There we go. Yeah, so it's like a 10-volt signal. Pretty big for audio, but that's what happens. So, yeah, these are just our weirdo waveforms from the Hajiwo module. It does weird stuff, which is kind of cool. That's just tune. That tunes it. I can see it tuning there. Okay, so we know that we are generating a waveform. What if we put the waveform into our filter here as an external audio source? Maybe our internal audio source is so messed up. These unscrew rather easily. It's not good. So let's see. The monitor output of the voltage-controlled filter, voltage-controlled filter CV, voltage-controlled oscillator out, voltage-controlled amplifier in, and filter in. So amplifier in and filter in are right here. So we're starting with filter, and we're going to see if we can see anything on the output, I guess. So we've already got output hooked up down there. Although I'll do purple out for this. So there's our overall output. And then we can do, this would be the square wave. We don't need to change the frequency of this one. So we're putting the square wave into, well, we don't need to put it into anything. And then we take audio out from here, and we put it into our filter in, which is, but this is the gate that we're setting off. There's filter in, and we're not getting anything on the output. Although this one might be, do we see noise? Yeah, noise. So we should be seeing an output. Filter that over there. We are going voltage controlled amplifier. This one will be gate. We are giving it gate signals. So yeah, it is still messed up. It still does not allow us to see audio on the outset. Volume control, nothing. Accent. Nope. Decay. Nope. Resonance. VCF mod. VCO mod. Cutoff. Nothing. Nothing. Envelope. Nothing. Okay, so now we check the voltage controlled amplifier. So I'll put this into the VCA, which is, that's envelope out, and this one is VCA in. Into VCA in. There is our voltage controlled amplifier functioning, although very quietly. So you can see that we are getting audio, albeit very quietly, out of the amplifier when we give it the control voltage that it wants. Although it is very quiet. So that might be damaged. Flip this to... Oh, there we go. There's VCA. So that would be our gate signal triggering stuff, so we know that the amplifier portion of this thing does function. Resonance all the way to none. Although the decay does not appear to be functioning as like I thought it would. Not doing anything. Turn this over to gate. There, now it's gating. Although, so VCF is what seems to be broken here. But this seems very quiet to me. This seems very, very quiet to me. That's just going to change the nature of the waveform. It's a little strange. I mean, we're also adding to the fray. Like, this is a thing that I built, so I don't know. I don't know about the functionality of this thing. We can observe it with the scope, and it's got like 10-volt audio, and then through this thing, it suddenly is like nothing. It's like 1-volt audio. Audio in the synthesizer goes up to 12, doesn't it? Like, aren't all the voltages up to 12, or is audio specifically 1 volt? That's what I don't know. This is the envelope output that's set up by the trigger. So it doesn't matter what I put in here. This is just creating an envelope based on our CV going in there and triggering it. So this would be the decay, and you can see how it sustains a little better. And if I turn the decay all the way up, to the left rather, now it decays very quickly on the envelope. Resonance doesn't seem to do a whole lot. I think that's filter resonance. Yeah, resonance is on the filter, sorry. Envelope mod. Don't know what that's doing. Doesn't seem to be doing anything. And then accent. Probably could hear it if if it was actually messing with a signal. Most oscillators try and normal to +5, -5. Control voltages are much greater than audio. So oscillators are at 5 volts. So that puts this out of spec. I wonder if I need to mess with my my circuit, because mine looks like this. Actually, that is very close to ±5. Why do those totally disable it? Oh, it's just different modes. Yeah, different waveform types that you can get on the oscillator. Okay, so anyway, if we put that through that audio signal into our filter, on the CVN, VCO CV, and then this one would be the filter input, we should be seeing it. There's no filter out on this, which is unfortunate. There's VCO out, and then VCA in and out, and a main output. So our main output down here, we should be seeing a signal. So if I put this into the voltage-controlled amplifier, I don't know why you would do this. It's getting a little loud. You can see that envelope then is doing the amplification of the signal. It is very much quieter though. That is a whole hell of a lot quieter than what we were getting before. And then this would be turning it into a gate signal, so that when the gate is high, we get audio, and when it's low, we don't. Yeah, So the envelope works. The amplifier, I guess, works. You know, it's not very loud. Actually cuts off right there. That is so weird. That's very quiet. It feels like it should have more punch in its I'm not gonna mess with that because it appears to be working though. Yeah, the Eurorack it's a mess. The standardization is a mess. But my very strong audio output is very much being tamped. That's what it should look like. Okay, so we verified that certain pieces of this thing are in fact still working. It's the pretty much all down to the voltage controlled filter. That's it. Because it appears, you know, this going on here with the envelope and the amplifier, you know, on off, that appears to work. It's quiet, but it appears to work. So it's down to that filter not functioning. And we know that we get a wave all the way into the filter, just not out of the filter. Something in the filter doesn't work. We replaced one of the main blocks of transistors where we see the signal get killed. And it's very difficult for us to test it anywhere else, because all the different features of this thing are locked away behind a sandwiched circuit board. We certainly aren't seeing this. Just voltage control filter. My concerns are that these are out of spec, and so it's not getting into the filter properly. But if we send it an external audio source into the filter, we don't see it on the outset. So there it is. There's your smoking gun. Something in this block of circuitry right here is dead. And so now we've got to find it. So the question is, do I ohm it out, or do I, like, we can test transistors in place using the diode tester. It's not a totally sanctioned thing, but since transistors essentially to a multimeter look like two diodes, two PN or NP junctions, or rather it's a structure made out of, we can do some diode testing on these things. Any way to create a ribbon cable to send? I literally just, where were you? You sit back down. No, the problem is these ribbon cables go through the board. Like, it's the standoff goes vertically, and so the ribbon cables that I got, they don't have the right orientation for me to do that. I really wanted to. I have 2 ribbon cables that I bought specifically for this without thinking about this stupid problem. But the problem being that I need the pins to flip in order to plug in. This is a very strange problem to have, because you have pin 1 in the same spot on all of these, but if your pin 1 is there, then you need pin 1 to be the exact opposite, or you need your connector on the other side of the board. I guess maybe, are there like left-hand ones of these plugs? Because you can't just take this out and reverse it. It doesn't work like that. That's not how IDC works. The way IDC works is you have these vampire clips that displace, hence IDC, insulation displacement connector, IDC. And so what happens inside of the IDC is these little clips make a connection to the wire. Take care of us. Like that. So if I were to make, I don't know, I'd have to like have those go to the other one. I'd have to reverse them somehow. You can't really pull, if I pull the connectors and put them back in, they'll still be offset in the same way. Too bad the board wasn't updated to use USB-C. I mean, you can get a lot of connections on a USB-C connector. You get a lot of connections. But this is the way you would do it if you were making the board yourself. So it's okay that they did the things the way they did. I would literally need for the clip to be made with the offset in the opposite direction. It would need to be offset to the other side, because you can't just pull this and put it into the other socket, because then it would still be offset in the same way that it was. It'd be so weird. So yeah, I don't know, maybe there's like a mirror connector somewhere. That'd be the most confusing part to have in your shop, but yeah, I can't just, you know, pull the connector and flip it in any way. Because like, I can have the wire exit either side of this, and pin 1 will still be pin 1 in the same way. I can't make that pin 1 go anywhere else. I would need that pin 1 to be on the other side of the cable. It's very confusing. The way to do it would be to go through a board. But yeah, I don't want to make a board in order to split all the stuff off. Old floppy cables have the ribbon cables separated so you could differentiate between A and B. Maybe you could separate each wire out, flip it that way. No, I don't want to do that. That's a lot of work. Yes, you could do that, but that's a lot of work. I mean, if I split it off in pairs or whatever and flip them, I don't know. That is a completely normal IDC cable. We used to have tons of them. We used to use them all over the place. Nowadays, the way to do it is you make your own little orange PCB cable connector. Then it doesn't take up any space. All right, so power off, and we're going to have to ohm out some stuff. How frustrating. At least we know that specifically the filter is to blame. Although I'm a little concerned about the lack of voltage coming out of this thing. But I guess that is normal. Our lawn guys are here too. Man, it's so annoying. I think they're done. Hopefully they mulched. We haven't had mulch for a while. And our lawn guys are actually Four Seasons Total Landscaping of political fame. That's the place we use. Yeah, you were hearing Four Seasons Total Landscaping. The actual Four Seasons Total Landscaping. I get all the way out to the burbs. Why did I see sparks? Did I see sparks? No. There's no way. There's no output. All the outputs are off. No, there's no way I saw sparks. Something sounded like sparks over there. But I think it was just scraping connectors. Okay. There are 4 lights. Let's get the scope at it. Unfortunately, the scope is like really fun, so naturally it doesn't have any purpose with what we're doing now. 2 more ribbon cables and a pin header to connect them. No. I don't think so. Let me think about this. If I'm connecting, this is like a spatial riddle. Well, first off, they don't really make good connection like this, so you'd have to solder 2 together, because this doesn't get you down to the metal. But if I did this without reversing the cable, actually, yes, that would work, but I don't have 2 more cables. So I would need another set of these. Which I don't have. Thinking about IDC cables that I have, I don't have them. No, I just don't have them. But yeah, that would actually work. So this would reverse pin 1 and pin 2. The odds and the evens would be flipped. There's a chance that you could get full continuity on that and then test around. And so that would be able to flip. This one cable can, yeah, that'll make this happen. So I could do this. Of course, that won't really help. Well, testing will be very annoying with this thing in the way, but oh, and the capacitors are in the way too. So I could do that. And then my pin 1s and 2s are all lined up. But I don't have all those parts. So, and I need to do the whole thing simultaneously. So by the time I get whatever I want done to get that done, it's already too much work. And I think the best way to do it given all of my resources, if I had two row headers, which I don't think I do, would be to solder onto the back a 2-row header and then plug into that, and then you'd have this big Frankenstein setup, but at least you could get to all these points, and then you'd be able to get to all the test points and stuff around this board, and then when you're done, desolder them, and then this would be back into its original configuration. Or I could plug this, remove it with hot air, put it on the back side. Hot air would probably be the best way, because I'd go in here, heat this up until it drops out, and then just solder it onto the other side. Cut the cables in half and make 4 from the 2. I don't have any more of these connectors. This is a... How many pins is that? My entire collection of IDCs. There might be other IDCs in another location, but I'm not sure. I don't have that size. Yeah, I don't have that size. No, listen, the best way to do this wouldn't be to make this weird collection of cables. Instead, just take this out, put it on the other side of the board. Solder the crappy soft jumpers for breadboards. Guys, I want to have 10,000 cables running off of this thing. All right, if you guys insist, then I'll flip the IDCs around, because it's not a hard thing to do. Just be a little tricky. So what I'm going to do is I'm going to plug in the IDC connector. That's going to keep everybody lined up during the heating process, and it'll keep this thing from disintegrating, because these are moody connectors. If you ever have to remove one of these and you have plenty of this stuff in stock, because you shouldn't ever remove one of these unless you've got plenty of this stuff in stock, you simply heat up the individual pins and pull them individually. It destroys the connector, but then you can solder a new one back in. In this case, I don't have an incredible... I have 1-row headers that I could put through that, but I want to try to preserve these, because, you know, I don't necessarily have them. So what I'm going to do is plug in the IDC cable connector, heat it from this end with hot air, keep away from this, because this will melt very easily. Heat this end with hot air until this drops, and it should just drop. I don't have an old hard drive cable. I got rid of as many IDC connectors around the shop as I could. Yeah, if I cut it and then I flipped the individual 1s and 2s and soldered it. I've done stuff like that before, but let's not get into that. That's why you never get rid of things. There's bound to be some IDCs sitting in the cable bin, but everything I know and love is in one room of this house. It's the only space that I get. So unfortunately I can't exactly be a pack rat. Otherwise I would have all that old test equipment that I could do cool stuff with. All that ancient test equipment. So what we'll do is we'll apply heat until this thing drops out, and then clean up the pads, clean up the holes with solder wick, solder it back in the other direction, on the other side rather. And that, in essence, is flipping the evens and the odds. That way I can plug the cable into one end and the other, and so the whole device will still work, but then we'll have room to plug or to poke in on this signal as it goes through stuff. Because we're kind of limited on the back here of what we could... The voltage controlled filter is this spot right here with all these through-hole transistor spots, and we can't really get to it. It's kind of a little daunting. So I want to be able to work on the front side of this, and this should be a pretty reversible operation. I could probably squirt some flux on this. Let's get some flux on here. I have a CRT refurbisher, not a tube tester though. It is essentially a tube. It's like a giant capacitor in a suitcase though. It's kind of crazy. Now, if that flux holds the heat in properly, it should just drop out, giving up all its hopes and ambitions. I don't think they glued anything down in this operation, so... Drop. Drop it. Drop it. Drop it. This is too much heat. I'm going to add some solder to this. So I got to be careful because this whole board is piping hot. But if I add a little bit of solder, it'll kind of wake it up. Huh? Where's my heat? There we go. Soldering iron fell asleep. I don't want to touch the board because I'll burn myself. We have narrowed it down to the filter though, so we know where to probe around for a signal. And with access to the front of the board, we should have a much easier time getting to everything. All right, so some new solder on there. This board is from 2014, so it really should not have crusty solder on it. The solder should be in relatively good shape. But I guess just adding volume to the solder helps me out. Volume and body. And that beautiful shine. Why is my electronics channel doing a shampoo commercial? What strange times these are. It's possible they used a less leaded solder on this. It's kind of what I'm seeing here. This is supposed to be easy. The auto solder sucker could probably do good here. Well, I'm tilting it so that I can kind of pry it out using just the weight of the connector. Is that melting? Nah, not melting. It's not flowing over yet. I just need to keep getting heat into the top layer of the board. It's going to take a little while. I don't know if this... I mean, Rojas, yeah, they probably... Problem is this can bleed out a lot of heat. This is where Chip Quick really comes in handy. This shit ain't moving. I don't know what's going on here. It's not really cooperating, and I don't really want to damage anything. I can drop some Chip Quick on it, I guess. If it was sold in Europe in 2014, yeah, you're right. You're right. Let's use Chip Quick. Chip Quick will make easy work of this. So I'm going to clamp the IDC connector. And just drop a big thing of Chip Quick on it. That I need to get out. Let that go through its cool cycle. Cool cycle. Chip Quick. Chip Quick is a solder alloy. It's not really solder. It's low temperature. Extremely low temperature. So what'll happen is I'll drop a little bit of Chip Quick on this thing and it will... Oh wow, look, something's like corroding in there. What in the world? Why are they like... They got bulges on them. Weird. But anyway, what I'll do is I'll drop a little bit of Chip Quick on it, and that will lower the temperature so much that I am able to work with this thing in a molten state longer. So all I need to do is get a little bit on each row of pins. Just a little tiny bit. And I'll lift up and heat it up at the same time. Once I get that worked in, I'm going to put more flux down. This is where you really need flux, because these pin headers bleed heat out. They're like big heat sinks. And the flux will just help everybody cooperate. I'm not forcing anything. I'm just lifting slightly as I go through. And by the power of Chip Quick, and Anime, it comes up clean. Now we use a lot of desolder braid in order to fix this up. So let's move on to the other one before we clean up. I guess I'll take the second thing over here. What we're doing is we're reversing the IDE cables because of the way they were laid out in the circuit. Means that I need my evens and odds to be flipped in order to plug a cable into these headers and have it take all the signals to the other PCB. We need access to the front of this thing because the voltage controlled filter doesn't work. And the voltage controlled filter is on the inside of the board, and something specific seems to be wrong with it, and we don't really know what that is. So this will help us access the other part of the board. A copper wire bridging all the pins and solder. That's a neat way to do it. This stuff is expensive. It's like $30 for this whole thing. So it's good to know ways that you can get around using Chip Quick. Yeah, I've seen people just lay on a giant thing of solder too to do this job. In this case, like a little bit of Chip Quick does go a long way, but it doesn't like to flow in. So you give it a lot of flux, and then it'll flow a little better, and it'll start alloying with your solder that's already down there. But you could also just put regular solder down and try to get a big enough blob. There we go. Boil that in flux. Ugh, nasty. Go, and then a light, very light lifting. And just keep the heat going back and forth until you've got all those BTUs in there. With IDE headers like this, it's important. Using something like Chip Quick, if I was using regular solder, I would want to be very careful that that heat has properly propagated the entire PCB. I want it to get all the way to the other side because I don't want it to lift off any of the pads for the header. That's a big problem when you do stuff like this. Right now, gravity should be pulling that Chip Quick into the other side, and all that heat should be held in there. With the help of flux, I should start to get this thing moving. It's not moving yet, though. I'm lifting very lightly. Come on, man. This couldn't be any smoother than it is. There it goes. It's starting. Now you're getting it. Starting to crunch and move a little bit. I mean, the easiest way for me to do this would have probably been to solder a header to the other side instead of going through this. Come on. Well, it's still sticking. It's not letting go, or it is very slowly. Seems like, oh, these over here didn't get any heat. That's why. I wasn't going far enough down the line. Oh, uh-oh. Need to concentrate on these a little bit. There we go. Jeez. Now inspect. Make sure that I got all my pads are still on there. Okay, good. That one looks a little iffy. Make sure I don't have any severed pads that had signals on them. I think they look okay. We'll check when we desolder everything. Whew. Man, that was a little rougher than I wanted it to be. Okay. I don't really have a good way to clamp this side of the board, so we'll just have to clean it up from here. I think the solder sucker might be the best way to do this. Used to be able to buy cheap solder that was like Chip Quick. Huh. Oh, they price matched and now it's expensive. All right, one at a time. This is where you get a thumb workout. And create a little pile of nasty stuff on the desk. Let's get a little closer for this. Visual ASMR. Cleaning up solder and chill stream. I mean, the real crazy people will remove it and then plug it in the same operation. If you got like a good hot air setup where everything's like preheated and everything. I don't think I can manage that one. Boy, they really had minimal pads on these headers. There's no room around them. That's a dog hair. That's going to smell like burning hair if I'm not careful. Oh well, you know what's cool about electronics is you've got an excuse to be inside on a very hot day. This one is a ground pin. No wonder it fought so hard. Oh, but I still cleaned it out nicely. Thanks to the magic of Chip Quick. Okay, I just punched the camera. Sorry. This thing just comedically punched the camera. You guys asked for this. You wanted me to do some wackadoodle method of getting to the other side of the board while the thing was in operation. You did this, not me. This is on you. The thing about the Engineer SSO2 is that it's got this little piece of 1/4 inch, 4mm ID, clear silicon rubber hose on the end. You can just buy this by the bushel. You don't have to get Chip Quick, or you don't have to get Engineer brand, you know, clear silicon tube. Please don't buy that. But cool thing is that little piece of silicon tube can exist at soldering temperature. And so you can use it to squish up against your solder joint so that it makes a seal so that you're actually pulling air through the through hole. And that makes this clean up so much better than the ones with like the plastic tip. I hate those ones. Those are my least favorite desoldering method. Now, assuming that our solder sucker did a good enough job, a pin header should just plug right in. We'll clean the flux up before we do that. But now I need to do this row here. So we'll do this row, and then I'll get the flux or the goof off out. Watch it sit in this test setup mode for a long amount of time. And like, I get Dave and Julian in here. And so Dave gets to see his beloved M303 eviscerated. Once we do all of this operation, I'll have schematics and stuff and a good layout of an M303 with modern parts that I happen to have. So it could lead to building one. It'd be funny if I made it entirely out of those flexi orange PCBs. Like the whole thing made out of flexible PCBs. like a big stack of them. Uh-oh, we're getting clogged. Got a big plug at the end. Bah. Yeah, you buy... I bought a kit. I shiver every... Oh, yeah, shudder every time I see them use it. When I become frustrated, let my equipment... It's only $20 or more. Yeah, some of my equipment I did actually spend a little bit of money on, but soldering kits have some pretty bad stuff in it sometimes. They're getting better though. I mean, all the stuff around electronics has totally changed since I was familiar with starting out. There's a lot of very useful things. Although I don't think anybody's ever used that heatsink clip that comes with the soldering kits. They give you this little clip, and it's like, oh, this is a heatsink, and you're like, when do I use that? Like, you never use it. Cameras are built 90% out of. Yeah, I know, aren't they, though? Having gone into the lenses... But like, corporations are insane with their ability to make flexi PCBs. Like, only in the past, like, couple years have the DIY PCB houses, the board houses, been able to support orange flexi PCB. You thought it would have come around a lot sooner, but now that they do, I'm tempted. I'm tempted to do one for my Pico Pi powered keyboard. If I can just access all the microcontroller pins with an orange flexi PCB, and then have it go to a Pico Pi with the two muxes. All right, my thumb is extremely tired now. Holy crap. Let's clean up the flux. Let's get the flux out of here. What'd you do on stream today? That's what I did. The heatsink clips were great. There's always somebody in chat that uses the thing that you think nobody uses. There's always the corner case. Everybody's a corner case. I don't take vitamins. I take every vitamin all the time. It's like, it never fails. All right, all this stuff is garbage, including this PCB right here. All of it, just garbage. And then I need Q-tips. I used up the Q-tips that I got. I keep them over by my other desk because I do not use them on my ears. I don't use them on my ears. I do not stick a Q-tip in my ear. I don't do that. Definitely do not. Chip Quick lives to fight another day. Although I don't know what the hell happened to my Chip Quick. I don't know why it's getting these little, like, bubbles on the end. I don't know if that's, like, moisture or a manufacturing defect or what. But Chip Quick is a sometimes food. It is expensive. It is weird to work with. It kind of gums things up. It works extraordinarily well if you need to get a surface mount part off of a board. But it's not for every part. You don't use it on, like, an LED. You use it on, like, the big thing that you want to keep. And you just flux Chip Quick a little tiny bit, and you move around. You just move around the chip, and then it'll fall off if it's not glued. What did you do on stream today? That's a good one. Hey, these things happen naturally, okay? All thanks to the degradation of my brain due to chemicals involved in electrical engineering. It's all part of the process. We're all Mad Hatters here. Mercurial to the end. I think I've tasted every chemical that's gone into a car. I really need to watch it around those chemicals. Look at how clean that is. Here, we'll get the other one close up. If it's going to clean off that good, we're going to want to see that close up. I mean, look, Chip Quick, I guess one of the other shop techs was using it. I don't know if they intended on it, but good Lord. It works so nice. So nice. It's just right. Bring this in here. Again, like, I don't mean to shill for a company. You can see how the flux is like drying on the outskirts here. I need to kind of pick up on that. One side to wash, the other side to dry, and to pick up any additional stuff. See that little extra? That's the stuff that was left behind. How's the other side look? The other side looks pretty clean. Except, that one looks a little funky. These three look a little funky. They're making good connections. I don't see any breaks. We'll look at it under the microscope in just a sec, just to be sure. So, all right, cleaning ability of goof off. Round one. A little drip there. I want to kind of clean that up. That also wets the other side. There's a big blob of flux that I'm up against. So I'm just kind of twisting and rubbing. Until it is done. Once I get all that up, it's still pretty well fluxed, but I'll just twist and rub with the other side. If I need to, yeah, it looks like I'll have to take another pass, but the next pass will get it completely clean. Same thing you do when you resin print. You actually, oh, I need another Q-tip. I didn't grab enough. When you resin print and you're cleaning off your prints, you have stages of cleaning, unless you have an ultrasonic an ultrasonic bath, in which case I guess you probably have only one stage, but you would have different stages of cleaning, because then the further stages can clean much more effectively. That was way too much. Hold on. Yep. Just like new. All right, so let's check out if we damaged it at all. Yeah, no smoking around this stuff. Were you able to make any progress with the resin printer? It has a house. I brought my Creality tent, and it barely fits the Elegoo. You can see in there, it's a little dark. I need to get containers with, yeah, the goof off is a very strong chemical. It smells like orange death, orange acetone, because I think that's all it is. But no, over here under the table, I will have my closable resin environment. So I'll be able to do a test print, hopefully soon. I hope soon. The short circuit video, the Computest, where there were a company making water blocks from 3D print. Yeah, I saw the thumbnail. It's pretty cool. Jet electroplating in the same place, model gains. I can't wait for them to be viable like regular printers. Oh, it's a special kind of electroplating printer? That's kind of cool. I have weld through spray that I can electroplate. That's all I got. But yeah, that's going to be my resin printing booth. I guess I won't be able to use the cover on the Elegoo, so I'm probably going to have to put some kind of a tint on the window for this thing, because this thing has a big clear window in front. I'll probably need a blocker for it. But I need to get like Tupperware containers to fill with the alcohol. It'd be nice and all to be able to see the print happening. And then I need to attach this to the printer, as well as space out the print bed. But this is the size of my print bed, by the way. I was watching a bunch of basic how-tos on resin printing, and a lot of them are like, the LCD is a consumable, like, part of the printer that's consumable, and it needs to be replaced after a certain number of prints. And I'm like, oh, good. I know there's a giant UV LED that'll eventually destroy any plastic in there, right? So the bed on it can print 50 to 100 dots in a 70 micron spot. Wow, wait, oh, so then you have maximum surface area exposure for your cooling stuff? That's pretty neato. So these are a mess. It would be nice if I had 2-row header. Let's see if I have 2-row header. I don't think I have a lot of 2-row header. Not how-to basic. Basic how-tos. Isn't How To Basic the one where everything goes, like, cascades into nonsense? Is that channel? Self-ruining mechanism. Well, I mean, you're putting an LCD in the presence of ultraviolet, and as somebody who has worked around oceanic sailing stuff, they are mortal enemies, ultraviolet and whatever. Ultraviolet ruins LCDs. It makes them constantly exposed. I don't know if I have enough two-row header to really do this. It's like drop some of it in. I do have one row header though. One row header can do. We can do 2 rows of 1 row header. Yeah, I don't have enough 2 row header. I don't really collect 2 row header. And the more I say 2 row header, the less I'm going to understand that word. I want to know where they got these, because these are nice. Two regular looking 1 row headers in a coat, in a trench coat. Like the light box I used to work to put the dots on the inside of the CRT screens when I worked in Philips. Huh. I mean, we took apart that printer and it is a giant LED. These don't interface so well. These are really meant for square headers, aren't they? Actually, I feel a little bit. No, that might make scratchy audio if I use these. So I can't use the rounded pins, which is almost entirely what I have. I need to find normal row headers like these. My collection has gotten a little weird. It's been skewing in directions that I don't want it to, that are not useful. How many pins are these things? This is a lot. Yeah, see, that doesn't cover the whole thing. How is this so difficult? How am I having trouble with this? Yeah, it'd be an LCD instead of a shadow mask. It's kind of neat. It's kind of the type of technology makes a lot of sense, but it is a totally different world of printing, and I don't know where all the pitfalls are going to be. I don't know what all the shortcomings are going to be. So I'm getting into it slowly. But yeah. All right, so 2 of these. I need more of this header material because I'm running out. We can just break them with these. Yeah, that'll be fine. I don't know where I think my clippers are on the other desk. All right. Don't fall in the pit of goo. Apparently, like, the resin can really hurt you. But I mean, I've worked with the resins before. I've used them in soldering. Okay, there's that. 1/4 of the way there. Aw, this is light by 1 pin. Are you kidding me? That is such ass. It's 1 pin short. It's straight from the devil's kitchen. Yeah, I get you on that one. Apparently, though, like when the washing resin fills up, like if your wash bin has too much dead resin in it, you just put it outside. Apparently, resin printers put things out to pasture a lot, and the sun will cure anything that's left over. There we go. So there's one, and the other one, this one is 2 pins short, so I can just take this and put it on the end. Now, the way that we keep it from being all janky, all jacked up is what I was trying to say. I almost said jacked off. Keep it from being all jacked up, what we do is we just plug in the pin header to it. You just plug it in, and then all's well. These are probably going to be ruined when I do when I reverse this, but this won't get reversed until the synthesizer's fixed. And when it does get reversed, I've got the ones that are plugged in on the other end of these cables that I can use. So this header I will use on this when the time comes. We're cleverly using all of our supplies here. Gotta be able to do the sequence just right. So what I can do is stabilize these with the plug. the plug thing. It's not plugged. So I can plug those in, and then I'll put this flat on the table, and then we can solder all the headers. Those in here. And I got to make sure that this is flat on the thing, so I'll probably put a hand on it and then solder them all. Oh, it looks like there's some mess up here. The solder sucker didn't quite clear off its mess. Okay, so let's get that on the microscope because it'll be a lot more digestible. The one thing you got to watch out when working with IDE cable like this is that it doesn't get into the way of the soldering iron. Many a time doing this sort of thing, you look at you go, wait, is it that familiar plastic burning smell that I detect? It's, oh shit, that is. My IDE cable's ruined. It's happened to me a lot. Let's get closer. What a mess this stream is. I thought that I was going to come in here with my entire hour of sleep last night. 1 whole hour, can you believe it? And we would replace the one part, and then this thing would work. And we could ride off into the sunset, and I'd finally have Dave's synthesizer fixed. I can't get in here because of these capacitors. Let's do it this way then. I thought that's what was going to happen today, but apparently not. And we need to go full-blown test mode with this. It's reversible, but this is heavy alteration to the circuit that I didn't expect to have to be done. But we've narrowed it down to the voltage-controlled filter, the VCF. So as such, why am I not getting any solder activity here? Hold on, let's go in like this. There we go. Actually, you know what? I'm going to get the larger solder for this. I need a lot of solder to be present very quickly. There. Big solder, come on. This one's not on a reel. What I hope is that my little fume hood will contain all of the smells of the resin printer. All right, so having to hold down the board while I'm doing this makes this a very janky process. This is very annoying. That's just flux right there, which could be to our advantage, actually, once we get some heat in here. Turns out it wasn't. Turns out there was no advantage. Does that look like a ripped up pad? It's not. It is a perfectly fine pad. All right, good. We got to be careful though, because we could have created problems by desoldering the pin header. We could have made more work for ourselves because of the destructive process and the nature of it. You know, sometimes it doesn't quite look like a pad has been ripped up, or maybe there is a microscopic crack in the whatever it is, in the trace layer. Had that happen before, and the way you get around that is you scrape up the solder mask on either side of the crack and then just load it up with solder, and then it'll bridge itself. Solder is pretty conductive. It's not very resistive. You might be adding a little bit to your circuit by adding a blob of solder, but it's not a lot. And maybe if you're doing like high-speed RF, it would be totally unacceptable to have a signal go through a solder blob because of the speedy nature of everything that needs to happen. But if you're in, especially an audio world like the rest of us, a little bit of resistance isn't going to mean much. All this work, and I'm gonna start probing around, and we're gonna find just like one cracked trace, and then that'll be it. Although it is possible that I need to replace all of these transistors. That might be what's going on. But we're doing all this work just to do that. Hey. But chat asked for it. They wanted this. They made this happen. You guys said, you went, what if, when I was messing around. So here's what if. This is the answer to your question. The onus is on you guys if this fails. No, it's not. No, it's not. I'm just being a streamer. You got to be a little hoity, a little haughty. Because it's just me out here. I got to make it. I'm fighting for my life. All right, I got to not burn myself, and I need to come down onto this thing at a high angle because there's not a lot of room to operate around this piece. When I solder it in the other way, when I flip it back over, it'll be dead easy because that front layer of the PCB can hold the square cable, or hold the pin header in place for me. Things are called things, and when you want to refer to things, you use the thing that they're called to refer to the thing. My fingers are getting closer and closer to the iron. Let's move back a little bit there and finish these last couple. Yeah, so in a pinch, I guess you could put a big piece of copper on the back, and I've got in-wall power cables sitting in the wire bin. I could have gotten a big solid conductor. But, okay, so what we have done now is we've effectively flipped our evens and odds. So now what I can do is if I plug one of these headers in, I can note the location of pin 1, which in this case, this one's a little bit crooked. It actually kind of wandered a little bit as I soldered it in. It's like my middle finger where it kind of bends a little bit at the end, which really bugs me. It's like body dysmorphism. If I close my fingers, my middle finger hits up against this one now. Very strange, and it's made handling guns a little bit differently too. A little different to me. Weird. It's not off by a lot, but anyway, that's what this pin header is doing too. It's off by just a little bit. So if I really wanted to, I could push on this thing on one end and move the soldering iron on the other, and maybe I'd even it out. But since this is still just a test setup, we don't have to really worry about that. All of these are connected to the right places. Uh-oh, you said the pew-pew word on stream? People know. And if people think that whatever, who cares? All right, so pin 1 is here. Pin 2 is below it, right? So if we have our front panel, which direction are we? Okay, so, oh boy, they're right outside the window. Oh my goodness. Really? Right in front of my 3D printer? I think they blew the window open a little bit. That introduced more hot air into this room. That's the last thing that I need. Okay, so pin 1 is this one. And so that should plug into pin 1 as this one right here in the front corner. So that it goes like that. This spatial acuity stuff always bites me in the ass. Like, there's no singular other force in electrical engineering that has caused so much annoyance and error and strife. So again, pin 1 is now this one on the top. Actually, I'll do it this way so both cables are moving out in the same direction, like that. So pin 1 is now the lower left, which makes it there to here. Pin 1 goes right here in this corner. And pin 1 over here, right there, and in the right corner. And that is now a separated front and back panel. It would have been nice if they could have designed this thing to have the electronics on the outside like that, but I guess considering what musicians put their frickin' modules through, like, I hear of these module creators doing stuff to like very specifically protect all the electronics. Mutable Instruments puts all of her stuff up here with these because they get sandwiched behind the front panel, and apparently that's necessary to protect things. I don't know what these musicians are doing out here, but they are not properly handling their electronics. Every single time, you guys will see, you'll see, Julian and Dave, they'll come over and they'll go, hey, can you fix this? And it looks like they took a hatchet to the back of the piece of electronics. You don't let pets go to a bad home. I don't know what these guys are out here doing to their stuff. Okay, so pin one, I gotta check every single time. Pin one, like this. Bada bing, okay. Now, our ins and outs. Ins and outs. Tune, slide in, CV in. That's the way we're organized, right? Yeah, okay, yeah. So this is the output we want to monitor. That's the main output. I don't know if we'll be able to see anything out of that. Oh my god, what is all this? Hold on a second. Holy shit. I gotta pull some of this apart, I think. Just so we know what wires are what. Can the top board have a thick ground plane covering all the components of the other board? Kinda. It wouldn't really be all that advantageous to do it that way. It doesn't really make that much of a difference. The amount of distance between the two boards is too great for it to really make that much of a difference. Unless it was very specifically RF, or unless it was an enveloping ground plane, which the ground plane on this thing does not envelop. It may have an envelope on it. Ha ha ha, audio joke. Be here all week, kids. I should probably make a BNC distribution panel. That would maybe be useful for me to build at some point. That would make doing this gate and the dual gate and CV square wave output would be a lot more manageable with some kind of a distribution thing. Or if do I have a Y cable? I don't know if I have a Y cable or not. Get out of my way, switch parts. Those things made it back into the setup. All right, all these wires there. This one is the probe. That one has immunity to clean up. This is our external VCO signal, or audio. So we're taking this and we're taking it to VCF in. So 1, 2, 3. There's the third one. So VCF in, audio in's going in here. But yeah, let me get that. That thing Wexo sent in like a million years ago. Back when Wexo was sending me a bunch of stuff. Anytime I had a slight struggle, something would arrive in the mail. You gotta let the streamer struggle. That's what all the drama is in streaming, right? You gotta utilize the stuff you have instead of just buying your way out of every problem. But anyway, I have this thing, which is covered in dust and is almost entirely useless. But in the occasional project where I need to hold up a big PCB, it does come in handy. So now I've got my circuit board all laid out for me. Is it in the same orientation as in the... It'll help me a whole lot to find stuff if I get these two to be in the same position. So that would be upside down. Is that the way? Yeah, that's the way I have it. Okay, cool. So they're in the same orientation on both. So we can find our way around this circuit a little bit more easily. And now we should be able to power it up and see all the waves going on. We actually don't need the external VCO. We don't need that because we're tracing the internal VCO. Although if I do plug it in, well, if all things considered, it probably goes up to the top layer and then jumps. Okay, hold on. We're kind of, I got way too many cables here. 1 second. I got to get the scope probe untangled. and then we'll get all of our doodads hooked up, and then we can see this thing in operation as we probe through the circuit. Kind of an unnecessary amount of work to get here, but it is a show, and I'm trying to make this stuff interesting, digestible, and fun. So this was the fun way to do it. All right, so into our scope goes our blue trace, which is going to be our probe trace. We put the scope up. Be the one labeled scope. Scope. No. Scope? No. Scope? That's not scope. That's my glucose level. My hot dogs! Looks like they're doing okay. Yes, this sign was necessary. No, I won't elaborate. I gotta use that one more. That's the microscope. Where's my scope? I really need to get that Stream Deck XL working. I need those extra buttons for all of the weird stuff that I've got. Okay, so circuit. I got the drawing of the circuit. We got the scope plugged in, which is making a low frequency control voltage. Just go back and forth, back and to the left. And we have our probe here, and that's this channel. And then we have an output from what? Well, actually, wait. First, we have our input here, and we'll put that into the CV input for the VCO. So that's the top left one. Actually, wait. CV in, and then VCO CV. What does that mean? Well, let's go to VCO CV. VCO CV. I could just do that. Nah, we'll leave them separate. VCO CV right here like this. And what that'll do is that'll create a wave that changes its frequency from the changing signal input. And we can observe it. I can observe it. We can put it on channel 2. Channel 2. Out of the VCO here. But we're not giving anything power yet. So now I can turn this on, and what we'll see is a very dirty square wave coming from here. Let's see. It's not drawing as much current as it used to. Is anything heating up like it shouldn't? This is getting quite warm. It should be okay. Oh, I'm upside down. That's why. Upside down. So we need VCO. So CV is this one. That one goes here. And then output goes here. Still nothing. Hold on. Hold on. Hold on. Hold for thought. Make sure everybody's plugged in the right way. The heat I saw on the board wasn't too bad. I think that was okay. Because, yeah, those are those, and then this goes down like that. That seems to be okay. And we double check. Let me just double check my ins and outs in case I flipped them. Bang. No. No, nothing exploded. Thank the maker. Let's see. From what I understand, those are plugged in correctly. Ah, that's my control voltage. And that's going into VCO CV. And then VCO out is up here. And that goes into channel 2. No, that goes into channel whatever. Hold on. Oh, no, this one's a... Okay, so this one's also a square wave. That one's my other square wave. This one's channel 2. I need to put, like, shrink wrap on these so I can identify which one's which. I don't need electro boom. I don't need to fill my life with explosions. Why is there a positive voltage level on that pin, on that output? Is 2 just offset? Oh, that turned it off. No, it's not offset. Why would it be like that? Huh. Okay, square wave, all that stuff. Let's try it again. There we go. Of course, the weird thing is it gets that jump in voltage for some reason. That may be one thing that's going on here. That may not be appropriate. You can see the frequency is changing though. And if I to the now the mod doesn't do anything. VCO mod, the VCO, yeah, VCO modulation. This makes the effect of the control signal more or less. So that changes how it reacts. So I guess it's not really 1 volt per octave. But yeah, we can see the changing frequency there as it rolls by. I don't need a faster oscillator. This needs to be nice and slow. I sat on my audio cable. That was weird. Okay, so into this whole business goes our signal. Should we maybe get this on the microscope, if I can manage that? I think so, because then you guys can see me individually poking pins and we can get a better idea of what the circuit kind of looks like. And if I put the scope up here, there's our signal. This is a lot closer, so things are a little bit more zoomed in. So we start, well, power's all the way over here. Oh, this is actually kind of annoying. Wait a minute. Okay, so our signal, according to my notes, starts off. Where is that? All right, so the switch that controls square wave or triangle wave is down here. It is on 1, 2, and then 3, 4, 5. So this one, and this one are our signal. And this is where we decide whether or not we want a square wave, as you can see that matches the output, or a triangle wave. There's the triangle wave. And so here we've selected square wave. So even though it's a little bit off camera, there it is, it's the square wave. So far, so good. I should probably get these to all be at the same voltage level, shouldn't I? Let's channel 1 is 6 volt. 2 is 15. Let's turn that to 6. There we go. Channel 3 is 6 volt, and 4 is also... Okay, now they're all at the same scale. So if something is off, then we know that it's off by like... It's like well above 6 volts. Like that one is sitting up there at on top of 6 volts, which is really weird. I think that may be somewhat of what is supposed to happen in this, though. Let me get this camera closer. All my cameras just zoomed in on this one thing. At least you can just see what I'm doing here. I think that's in focus. I'm not totally sure about that. So anyway, our signal output is coming from this pin. And so that goes down, and oh God, where is that one going? It goes down to this capacitor here. So we can pick it up right there. So there's that signal. From that capacitor, it goes under the board. Does it? Hold on. What the fuck? Where's that one going? I actually don't know where it goes from there. Hold on a second. Wait a minute. I've been bamboozled. So the middle's here, it goes down to the capacitor, and then nothing. Nothing at all. So does it go down to that transistor or something else? Unless there's something under the board. No, it doesn't look like there is. The problem with this section is that I forgot to flip to another layer to jot down what was going on. Let's probe around. Let's probe around. I mean, it's like two filter. My notation is now fleeting. I don't know what any of it means. I guess this is the audio path though. It goes through this capacitor to this resistor, and then those go to the other layer of the board, and we don't know where that goes. To F. Ah, damn it! Stop scrolling. And here's it comes from the filter this way, or is that it says F in as my notes on that. So what's going on with this 2.2K? Let's just check up on the 2.2K. Can't see the microscope in this view. This is where multi-monitors come in handy. If I had multi-monitors, I could put the schematic up on one and stuff like that. What a cool stream. I wish I could understand something, but it sounds... Yeah, look, right now we're probing around. Probing around the board and just getting to know where this audio path is. There is a signal on this, but it is very high indeed. Or not. Wait a minute. Never seen napkin math on a photo before? Have you truly worked with circuits then? If you have not done a napkin math. Oh, look at that. That actually answers a question for us. Now I know. Now, did I predict it correctly? I did not. I did not. Yeah, look at this. I can actually correct something here. So these traces are not correct. Let's go back to that layer. Do a little eyedropper action here. Actually, it'll probably be in the history. Yeah, there it is. And then go to whichever layer is this one. Oh, why is it like that? I must have drawn on the original image. That's not good. I wasn't as disciplined as I should have been when making this. Here, I'm just going to do... Why is it a circular selection? Where's my square selection? Oh, you know what? It's right there. Ah, yes. It's called being scrolled out. All right, so all y'all is dead. And although it does look like there's stuff under it, it shouldn't be. Select none. I've been watching H-Bomber guy videos, so I've been saying my none as if I'm Welsh for some reason. It doesn't matter if that goes off to the side. What is this? Oh, that's a trace on the underside of the board. Okay, well, wherever that one went, I'll have to figure that one out later. But right now, what I can do is correct all this shenanigans. Put pins on that just to make it nice. And then this one clearly connects right there. But the rest of it, I need to have like 1,000 things open at once. That one goes there. This one goes, oh, to the same one that, okay, so that's a path. So there's that. I need to make that a little bit more clear. I know you guys can't see what I'm doing right now, but I'm just sketching it in the other thing. So this first one, nothing is connected to it. Second one, that one goes in and through. The one that goes diagonal and above. Third one just goes straight in. And then everything else is happening on the other layer. Any other shenanigans on this one? Nope. What about on the other one? You have any shenanigans? A little bit of shenanigans. What's that place you like, Farva, with all the funny crap on the walls? Hold on. Correcting my work. GIMP is very clunky. I have a feeling it's going to see a little uptick in usage, though. Because Adobe is just absolutely tone deaf. Okay, so now I'm coming up to... I can't see the microscope without making you guys see it. up to this one up here. Now we have a couple answers. Even though I might have ohmed this out. I might have ohmed this out, and I might be correct about what's going on. Let's just see. I got that one right as the 4th pin in. Is that right? 1, 2, 3, 4, yeah. So that one's correct. Let's see. Yes, 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 yes. And then, oh, which one is that? That one is 1, 2, 3, 4. 1, 2, 3, 4. On the 3rd pin goes down and to the other direction. See, I got this one wrong. It's good to make these corrections. The more we uncover, I mean, these are things that I could have ohmed out as well. I could have just taken a multimeter too, but I guess I must have gotten it wrong. Because this one goes like this. Which makes sense that they would use every pin. I'm assuming that one goes like that. Let's just see. That's not what I wanted to look at. Yeah, those just go straight up into there. There's only a couple little weirdnesses, but for the most part. Okay, cool. Now I've now verified all the stuff that's under some of the parts of this. All right, so we are tracing our signal, and we started, well, I mean, technically it's going to start over by the oscillator, but we don't really know what's going on over there. This is a crazy town full of madness, and I don't really know where the exit to that is. There is a TL072 right here, which would hint at that being the output stage of this thing. Because if I go to the schematic, well, our outputs are coming from that switch. That's kind of where we grabbed them. Oh, so that isn't, so the TL072 isn't doing that. It's doing something to do with the oscillation. All right, well, anyway, yeah, see, there's a limiter, Schottky barrier, or whatever it is, a Schottky, or whatever, over, under, I don't know what to call it. But our waves are coming out here. And here they are starting at 5 volts and starting at 5.5 volts, which is what we observed. Our scope is on 6 volts. And so our waves are all the way up in Crazy Town. So those actually do stand to reason. I think that maybe the specs are the same, which is nice because that means that we can actually use this document to troubleshoot it a little bit more. But anyway, away goes our square and triangle, and in comes our triangle or square from the switch. That one goes down to this 220K resistor and C17. So if I go back over here, I need one more view on this window, and that needs to be the schematic. Oh God, I think I have that here somewhere. Wait, face cam, stand cam, point, pont. No. Oh, that's the MS Paint. Well, all right, fine. We don't have MS Paint up anyway. You guys don't get the schematic. I get the schematic though. So we know where that resistor is. We know exactly where that resistor is. We know that that resistor is right here. And so if I look on one side of this resistor, we get almost the exact same wave. There's got to be a better way that I can display this. Hold on. It's got to be a better scope display. It's hard to see some of the stuff that's like in the background there. Oh, whoops. Sorry. I was changing the voltage. Let's go to the... I always just reach for the wrong thing, don't I? What are we triggering on? I think we're triggering on channel 2, but I don't have anything going on channel 2. So I'm going to trigger on channel 1. Oh, I am triggered on channel 1. Okay. This is a little bit of a clunky view, though. I guess we'll just go back to rolling scope. It's just hard to see the details as they roll by too quickly, you know? But what we're looking for is our signal to go through the filter. So here it is coming in, and it's the red trace. Maybe we should swap our red and our blue. Yeah, let's swap red and blue. I'm going to put the oscilloscope, or the VCO output on the... Wait, hold on, wait a minute. Why did we see that on purple channel? We should have seen that on channel... Oh, geez. Okay, hold on. So channel 1 is still our wave. Channel 2 is going to be our probe because it's much easier to see. Channel 3 is going to be the output from the oscillator, and channel 4 is going to be our overall output. There. So, oops. Now I just got to, my BNC cables are a little bit janky. Okay, there we go. So now the bright trace should be our waveform. There we go. The one that's easier to see amidst everything. So there it is on one side of the resistor, and then on the other side of the resistor, it's going to be just slightly less or so. Hello? What about right here? Hello? Let's get channel 3 out of the way. Signal? No signal. What? Say what? I thought this is a pathway to powers some might consider unnatural. Let's go up here. Right here. Oh. Huh. So maybe this is a filter. I keep, every now and then a dog hair will fly by the video window, and I'll think something is on fire because it looks like a little wisp of smoke. Okay, so it goes to that resistor and it dies. And that's either something on the other side of the resistor pulling it down into nothing, or something's wrong here. It doesn't branch off anywhere. According to what we can see of the circuit, it doesn't appear that it branches off anywhere, unless somehow, well, then that trace doesn't make any sense. Yeah, this makes sense. This area of the board makes perfect sense in terms of its top and bottom layer, right? Yeah, thank you guys for the well wishes on how cool the stream is. We're having a time right now, and hopefully this all boils down to an easy problem to fix, but I'm just not sure. I'm just not sure. Now, I don't think that resistor's broken because we've tested that resistor about 500 ways, right? We've done the testing outside of the traces. I've tested places that this connects. Like, I've tested the other side of that resistor through the resistor from other parts of the board. So I know that that resistor is connected in there, and it's just fine. The question is, what's happening as it moves into the chip? I could pull the chip and see if our signal gets all the way up to it. I can also look over here and see if there's any problems with whatever the heck's going on here. I think there's a resistor and a capacitor to ground. That would be here. What's going on up there? That is that. That connects there. Geez, this is a strange filter structure over here, and I don't know if it's an exact so far, things have been an exact replica, but they could change it up a little bit. Like, that's all this stuff down here. The C16 to ground, 2.2K to what I have to assume is 5 volts. Let's see what that symbol means. The circle with a line horizontally through it. That'll be up by the power supply that they'll detail these. Well, there they have things with an arrow and a voltage call out, which I appreciate more, but the 5.333, that's what our LF353 or whatever, there's a voltage regulator, adjustable voltage regulator chip that's creating 5.333, and we have measured that. So that's what that symbol is, the steering wheel looking thing. Down here, we have a steering wheel looking thing. So our 5 volts, where the hell are we? Oh, they have a block where they tell you what it is. Roland is awesome. Roland has been very cool. You know, I'm like, son of a bitch, what does that thing mean? How could they do this to me? I have to flip to another page. Now they have a note right there for me. It's almost like somebody like me made this. So yeah, we've got our 5.2 volts, which I guess is just a halfway reference for control voltages. On this whole bippity boppity thing, all this crazy shit that's going on. Going into the transistors over there. This is where things just get crazy. But like, by all means, the resistor and capacitor going to ground should not kill our signal and turn it into a steady 5.2. I don't think. It's coming in here to Q12, and I've got an inline capacitor who on the other side of, I should be getting a voltage level. So something's up. If I flow the solder on either end of that resistor, I wonder if I could then get something out of it. The capacitor here did measure to 1 microfarad. And yet, signal here, no signal here. What bugs me is that I ohmed it. I ohmed it out. I'm gonna reflow the solder on this thing. Maybe there's a crack in the resistor or something. So power off. Oop. Clean this off. Turn on the soldering iron, of course. Get a little tiny bit of solder. We'll just poke the other side there. I do feel like it's the other parts of the circuit that are not allowing this thing to function properly, but we'll just try this because it seems to be what's going on. It might not actually be what's going on. It's good. Hit this side. And the board is circa 2014, so it's not early RoHS solder. I don't think the solder could like go bad. That's absurd. No way. And I was ohming this out. This thing has values for the multimeter. This is troubleshooting electronics like this involves every tool in the shop, every single one. It's a very complicated thing. All right, power back on with a slightly hotter resistor. Boop. And we should get on channel 3 here. We are getting our wave. It's just kind of working itself out. Why did that turn off channel 1? No, oh, because I touched it. Series resistor 220K and a resistor 2.2K to the 5.33 ref voltage. So expect a voltage reduction of around 100 times. Whether just a voltage divider circuit. This does not strike me as a 100x reduction, though. I mean, if I jack it up, channel 2, is it? Yeah, it's channel 2. Channel 2. I jack it way up. That's not the, I mean, we're not dealing with a triangle wave. I can flip it to the triangle wave. I can get, here, hold on. That should look like a square wave, and it really doesn't. So triangle wave like that. Whoa. Well, there, it just went away. Back to square wave. Oh, it's going to take a minute. Something in the circuit is doing weird stuff to our waves. Yeah, see, here it comes back down from outer space. There it is. Yeah, it's less that... Well, actually, wait, what happens if I adjust, like, resonance and stuff? Hey, wonky robot. How you doing? The wonkiest of robots. Sorry, I can't reach the controls of that. Which one with filter? VCF mod. That's this one that I'm adjusting here. Doesn't appear to do anything. What is the other one? Resonance? No, that's part of the envelope. And then cutoff. I'm wondering if we're seeing the effect of the cutoff. That's VCO mod, so that one is definitely adjusting stuff. You can see it changing frequencies as I mess with it. And then this one should be, well, we're not even looking in the filter yet. We haven't even gotten to the filter. So the fact that this got destroyed like that, and the signal looks all weird. Then again, this is not necessarily in spec either. This is a sub 1 volt signal. It's just that it gets completely eliminated here. Yeah, this one is, it is a little funny right here. So at the output, what are the specs supposed to be? According to this. Now, again, the specs could be, the specs could be different between Audio Labs and, you know, Roland? Who made this? Yeah, Roland. Roland could have different specs. They give us the voltage levels. They say 5.5 volts to 12, and then 5 volts to 8. So on those lines, which would be down here at the header, we can take a look at that. And I can adjust the potentiometers now too to see if that's what's doing weird stuff. So over here on this pin and this pin, we have our triangle and our square waves. So here's this one, and this one starts, well, it starts at around 5, and it goes to 10, although that's hard to see because of the granularity of my scope. So if we make the signal big and I bring it down, so that we're on 0. Where is that? I can't see it because of all the noise of the scope. 5.4 to a little over, yeah, to a little over. And then the triangle is in space. Where is it? It should be here. Oh wait, that's not the right one. That's the output. This one should be triangle. Triangle's all over the place. Triangle's all the way down there at 4 volts, whereas that's not where it should be. So there might be some adjustments that need to be done. Let's see what these potentiometers do for our waves. I've got 2 potentiometers in the corner, and I can see what effect they have on our squares and our triangles. The square is a little funky looking though. It should have a little bump to it, but not that much of a bump. I'm trying to get purchase on this thing so I can both adjust and measure at the same time. Here we go. Is anything happening? Doesn't look like it. No, okay. You know what I'm going to do? I'm going to get rid of the CV there. Now it's just steady. Actually, I pulled on it too hard. What in the world's going on there? Oscillator output. All this stuff is still connected. I just bumped a power thing. It's just we're not getting an output. What happened? What I did? I don't think it's that janky. No, this should be fine. Well, that killed that just by virtue of it being so bad of a connection. These BNCs are not great. In general, BNCs are usually really great at signals, but these are just a little bit weird. Oh, so move that off. In fact, just get the whole VCO out of here. Hopefully I didn't blow it up just then. Make sure my power jumps are good. You guys are good, you guys are good, you guys are good. Everybody's all powered up in this board. Then why am I not getting an output? Put the VCO back in. Actually, the control voltage back in. Why is it not working? All right, off and on again. Well, now nothing is happening. No matter what wave I select. Power thing, is it a... I think so. All right, why did my setup die? I bumped something and lost output. is the channel off. That output is going to channel 3. Yeah, turn the channel off. Okay, there we go. So unplug that. All right, so now we're at the same frequency always. I'm going to turn channel 1 off. And now channel 3 is what we're looking at in order to tune this thing. I don't know if I'll tune it specifically to a frequency, but there we go. Okay, so channel 3 put itself onto the trigger line. Yeah, that'll do. Okay. So now what changes when I mess with these things, these two pots? Well, this one's not doing anything. Is that adjusting the frequency? I think it's adjusting the frequency. They're getting wider. Yes. Okay, so this is a frequency adjust. So let's mark that down. That one would be the top one. Here, down here. And I'll go to, let's see, we're on the top layer. So I can just take my pencil and just do freak. And then what would the bottom one be? It appears to not be adjusting anything. Let me flip to the triangle wave. That'll eventually settle in. It is at very much the wrong frequency, or the wrong whatever. Yeah, it's not supposed to be moving like that, so something else is still wrong. What happens if I adjust this? I don't see him changing. All right, what are my possible adjustments in this area? What does the schematic say? We're trying to get our bearings in this circuit here. Excuse me, I don't mean to cough on camera. I ran out of liquid. My dog just goes, "Perf." TM4, TM5. Tune and width. Set tuning CV output for 2.75 volts. Width is 1 octave per volt. Okay, well, in order to do that, did you replace the transistor IC? Yeah, I did, and it didn't really have any effect. We're not sure why our signal dies at a certain point. But in order to tune this, I guess I can do width is 1 octave volt, tune 110 hertz with CV out 2.75 volt. So I can do that with the Agilent power supply. It's such a pain in the ass to set up, though. I guess I could do signal clips on it. Yeah, I'm going to have to. All right, so let's get this thing tuned, just so we know we're doing the right thing. It's just those voltage levels aren't right. So I don't know. Maybe tuning it's a bad idea right now. But if I use clips, I can do, on a 6 volt, I can give it 2.75 on the power supply over here. So this, we'll go to 2, and then 7, and this one goes to 5. This is a very accurate power supply, so very, very, very accurate. So this is plus 6 volts that I've taken to 2.75, and now I need to hook it up, so I'll use clip leads. I don't know if I still have, I think I have somewhere around here, I have a headphone plug to 1/4-inch jack that I made. What just fell on the ground? That was my screwdriver that I need. Okay, hold on. Get my screwdriver here. That looks funky? What looks funky? The triangle wave looks kind of in spec. It could use a little bit little bit of help, but I guess they have a test point for tuning, huh? TP5. CV key. C is equal to 1 volt. C something or other 4 volt. Oh, I see. Yeah, they put all this information in the schematic. It's really nice. All right, let's see here. So we need a frequency adjust thing on this. So we need to do measure channel 3, and we will want time, and we want freak. There's our freak. 29.25 hertz. 29? Well, we haven't given it the CV yet. So 2.74 volts, but ground to ground. These will not stay clipped, and they're going to get very annoying. Yeah, they're not going to stay clipped. Let me find my tester cable. It's so much easier to use than this. It might be in this corner still. It's not. It's going to be in the drawer. Now that I have drawers, I have actual places to store these weird little things that I cook up. Weird cables and stuff. To help me test things. Although I seem to have misplaced the specific cable that I'm looking for right now, of course. Of course, it's not where I thought it was. Maybe it's over by the synthesizer. I can't believe we haven't gotten anywhere with this. Hey, Pyro. We haven't gotten anywhere. We just know more about nothing. Now I can do bad math quickly. Let's see, where did that adapter go? It's not in here. All right, fine. Where is the thing that I made? I made a little cable for doing this, for tuning up those mutable instruments things. Let me see. If I were storing something like that, it would probably be thrown or buried. Thrown or buried. Which is the fate of most of us anyway. Way back here. I don't see it. I don't see it. I have exactly the cable that I need in order to do this. We're basically just tuning an oscillator, and we need to set it to a known thing, and then the scope will do a little bit of our work for us in terms of measuring the specific frequency. And I know I can trust it because well, it's a new scope. It's got all the math menus in the world to help me do this task. And I had just the right thing for this. It's gone. I organized it out of existence. Chat's saying, same stuff as before. Now, it's not like I didn't think I was like done with synthesizers. It should be still around for tuning purposes. It was a spiral wrapped headphone cable. So by all means, it should still be somewhere that I can locate it. Doesn't help that I'm operating on a deficit of sleep. And then after stream today, I have to do uploads, otherwise it's gonna lapse. You gotta keep those dailies going. I do not know what I did with this thing. Let's check the drawers again. I'm just trying to tell you guys what I'm going through here as I make all these noises, because I'm not moving cameras right now. I've got this almost static image while I feverishly root through all of my drawers to try to find a cable that I made 6 months ago. Here it is. You knew I'd find it. All right, so this I can just poke into here. And now we have a controllable control voltage. We have a very accurate control voltage and a very accurate scope. So that should be 110 hertz. It's 46. So now we need to modulate the frequency up until we get to 110. Looks like we'll be able to do that easily. Why does it only go up to 56? Only goes up to 56. Huh. The scope is so wide. For some reason, this trigger is just not... Why is it jumping around so much? There. Yeah, it keeps moving it around like that. Something to do with the mode that I'm in? Or just the type of trigger that it is. Trigger on channel... Oh, yeah, it's not triggering on the right channel. It should be triggering on channel 1. Or channel 3. Oop. Yeah. Rock solid. Okay, frequency of channel 3 is 56 hertz. The control voltage that I'm giving it is 2.748. What's going on there? 2.75. But it's at 56 hertz when it's supposed to be 110. Oh, well, also the knob needs to be on the ball detent. Hold on. It is. I can only get it up to 86. Strange. Yeah, it'll go down, but it won't go up from here. And this other adjustment, is it the difference between the transistors, maybe? The two different devices. I have a slight different part number for that ultra matched, super matched transistor, but I don't think that's gonna do that. That or this works differently. I don't know. It says width and tune. Width is 1 octave per volt. So if I do... Yeah, if I do 1 volt versus 4 volts, so we need to go back to volt and octave. Oh, but that's CV. Which one is that? That's not an adjustment that I have. The width would be the tuning of how it reacts to 1, plus 1. And so 3.75 volts would equate to the frequency that is the next key. And you go back and forth until you tune it. Oct per volt tune. Shut the fuck up, AI. I don't want to know what you have to say. I fucking hate AI. All right, let's see. Octave voltage. I don't care about that number. I need to know frequency. Per volt frequency. Oop. There are tables that can help you adjust these things. I think a text table is probably the way to go, right? I mean, yeah, but all of the VCO adjustment is on. It shouldn't be adding that much. It shouldn't be altering our volt to that degree. Table. We'll just search everything. Oh, that might have been the one that I wanted. Yeah. Of course, it's Reddit, and then that's going to ask me, hey, do you want to dox your email? Oh, no, it isn't. Okay, good. This doesn't have a voltage on it. Damn it. Why are we doing log calculations? And I just need a number so I can tune this thing. We found a good table. It was on part of one of the other ones that we were working on. I don't know where it is. Hertz, volts, octave calculator. I just need a couple numbers that I can switch between. It was like you do like 1 volt and then 4 volts, and you would tune those, and you'd keep going from 1 to 4 until everything matched in, and then it would be all good. VCO tune table. I have it marked down on one of the other projects. Because yeah, audio does not work. Notes and the correlation between notes and, you know, voltages and oscillations and frequencies, it's all crazy. And if you, for the VCO, 1 volt per octave, you should be able to give it just tuning range, frequency range, gigahertz? I don't think so. Keysight Knowledge Center. VCO tab. This is like RF. This is like VCO and RF, huh? Yeah, this is ridiculous. All right, well, at some point I'll have to pull something up in order to tune this, but that's not, I guess that's not wholly necessary right now. It's just that I'm just trying to see, like, I don't know if maybe something is wrong closer to the VCO. If the VCO is not doing stuff it should be doing properly, and part of my thoughts on that is that when this thing powers up, well, those are with the capacitors charged, I guess. When this thing powers up, it, like, the voltage is all crazy go nuts. Like that. This climbing down to where the rest of us are. Also, it's very annoying that this thing is so janky. Just set my scope up a little better. There we go. Because, see, that climbed down to the voltage level, and now it exists on the number line, or it eventually does. It takes it a little bit. It's doing some weird stuff. So I don't know where else I need to probe into this thing. Maybe I need to read up about this a little bit. The oscillator in question. Need to know more about the TB303 than I ever even wanted to start knowing, because I don't know what happens around here. Those are 2 adjustments on the oscillator, and then we have 5 volt comparing to there. There's some more stuff over here, and then it highlights our 2 outputs here. So we've got up to 12 volts, which is not what ours is doing. Ours is not going up to 12 volts, nor is the square wave going up to 8 volts, although they're both kind of close to that. They're both very close to that. Because we know where to pick up on them. They're out here, going to the switch. Let's turn this channel on. Out here close to the switch, and we can see that I didn't turn the channel on. Oh, they're here. There we go. So one of them is supposed to be maximum 8 volts, but this one is spiking above. Spikes almost to 9 volts. The square wave maximum 8 volts, minimum is 5. So we're out of spec just a little bit, but that does look like the wave that we're supposed to see from the schematic. But when we get to the triangle wave, Triangle Man hates Person Man, it is maximum 4 volts. It's supposed to be all the way up at 12. It should go from 12 to 5.5. So where does our triangle wave come from? But then again, if we just feed it the square wave, we should be seeing it on the other side of the filter. So something else is messed up in the filter. Something else is messed up in the filter. Because over here, on one side of the resistor, we get We get nothing? Good day to you, sir. Oh, maybe I need to flip... No, that's triangle wave. Yeah, so there's our output there. And if I go to this side of this resistor, I should be getting a signal. I am not. What I'm getting might surprise you. It's nothing. Oh, because we're funky. Yeah. So set this one back and then bring is it zoomed in enough? Yeah. Well, there it's in the exact same specifications as the output. It's literally right on top of it. And that's what's being sent to the next stage. Do we have any? We don't have any data on what it should look like at the next stage. But it should be much, I mean, it should look like this on the other side of the switch. And it doesn't. It looks like the output, whatever's being output from the whole system. Right, saw wave. It's not a triangle wave. I just keep calling it the wrong thing. I see my nose in front of my face. Sure as hell aren't seeing whatever the hell that is. We don't see that. But I'm having trouble right here. This is where we're having trouble. It's this 220 kilo ohm resistor. We can come up all the way to it. And then after it, nothing. And if our circuit is different, which in some cases it probably is, a lot of what we're seeing here is that these things, it's like a pretty faithful reproduction so far, just with a lot of the fat cut off. And I don't know whether or not this is a faithful reproduction, but we do see a lot of very similar structures. So I'm seeing a wave that resembles this square wave, kind of, but not the triangle wave. And it's, I just don't know. I don't know. How come at the resistor I'm seeing it centered on the axis like that, though? That shouldn't be positive, negative. That should still be positive because it's only gone through. Maybe it's hitting a capacitor somewhere else. Like if I tested here, this would be the common node from the switch. This would be the common. So whatever's coming out here, we would see. How come I'm not seeing anything there? Oh, because it's very negative. I am confused. That's me. Record scratch. So you're probably wondering how I got here. Yeah, my wobulations will not be categorized appropriately. They seem to be wobulating in a very wibbly manner that I'm not approving of. Let's see if it, wait, does it hit a capacitor anywhere else? Hold on. So if I go back here and I take a look here and I do a little sanity check and we come back over to the connector. Where do my markings go for that? Oh, there they are. Oh, so this is where it hits the capacitor. Okay. Okay, so that's why it's centered on the number line, because it hits the capacitor right here, and this one eliminates the AC component of it, or the DC component of it, which means that it then centers itself on the axis. So right here, I get, on one side, I get a crazy signal that I don't even see on this number line, and then if I come over to the other side, the DC component is gone, and it is a maximum of 2 volts for some reason, which seems like not a lot because we were coming from 5 volts. We had it so that it was from 5 to 12. 6, 7, 8, 9, 10, 11, 12. 7 volts. When it's on the other side of the capacitor, it should be 3 and 3. Yeah, I guess that's where we are, huh? Seems to be where we are. 3 and 3. So it's a little bit out of spec because it doesn't quite get to 3 and 3, but it seems to be in an acceptable range. Because, yeah, the capacitor and then losses along the way. That seems like a lot of losses, though. Is this loss? That one's loss. And then this one's loss. Well, that one's exactly the output. So that might be where they split it out to the front connector. So far, so good, right? Everything seems to be within spec. It might be out of tune, but it's still within spec. So then the signal's sent out. Both of these are sent out, and they travel all the way over to here, where they join up. Where's that coming from? That's a gate signal input. Where's the... I guess they added a separate output. So yeah, here are our triangle or square waves, and we select them by flipping this switch. From that switch, our first stop is a resistor capacitor. These two, which we have, and then they've taken another output. So what they have is up here, they have another output that goes to the front panel. So that's that would be this right here. This one right here would be the output. We can mark that down. Write that down, write that down. I'm gonna sneeze. Woo, okay. Markdown layer, which one is that gonna be? This one, I guess. So that, and then OUT, I guess. Okay, that one goes out, and then this one goes to filter. And then it comes back from whatever it just hit. Here? At in? Well, that one doesn't appear to plug into anything. Where does that one go? Oh, I see, it goes out that way. On the other layer. Okay, so yeah, that I'll have to correct that later. But that filter in goes out this way along this line, where it goes under whatever this chip is, whatever this one's doing. This is where it's creating the frequency, but it goes under this stuff because it's getting out of here. It's getting out of this part of the board and it's going over to another section of the board. And so it's doing this dance where it comes up and down in order to jump over stuff. I've done this before in schematics where you have this big comprehensive schematic and you're like, I got to get over to this section. You know, you build your different sections of a board and then you put them all together and then you go, oh, I need to connect this to there. So we need to travel. We need to go for a little journey here. So that's what this signal's doing. It's going on a little journey and it's going under other sections in order to eventually wind up over here in our filter. So it's coming around here over to that pin. We have traced it to these pins. That's why I have them marked down like this. And it goes down and goes horizontal, and then it hits this first resistor. So we're actually not where I thought we were. I thought we were out here. It hits this resistor, and then this is the capacitor. So it's no wonder we saw nothing on the other lines, because over here we have a 2.2K resistor that goes to the positive 5. So this is actually very representative of what's here. So our frequency should go to one of the pins of the transistor array, but I'm not seeing that. On one of these pins, we should see our square wave. Let's find it. Let's find our square wave. Is it you? It is. No, it's not. Is it you? No. 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 How about this one? No. This one? No. I mean, this thing is broken, so it would stand to reason that we may not be able to pick up on the signal. We do know exactly what the traces are doing under this chip, though, and we didn't see it obviously going to any of them. Of course, I could have also put the wrong piece of electronics in there. We're moderately sure that this thing is another one of these transistor arrays, but it could actually be something else. It might not be that. It just seems logic would dictate that it would be that. But maybe it's not. But then where the hell is our signal going? Like, it has to be that. If that other pin, well, that other pin doesn't go to ground. That one goes over to there. That's a ground. But then where's our signal? I don't know where it goes. I've lost our wave. I mean, I should by all means be getting a wave on the other side of this resistor, but I mean, assuming that goes into there, it goes there to die. Why does it go there to die? It should not be going there to die. It should be going there to distribute. And yet all evidence would point at it going to this resistor right here to die. It comes in, goes to there, doesn't go anywhere else, and on the other side of the board, it's very clear what's going on in this area. Why does it feel like I have a pin in the bottom of my hand? It must have brushed on something. Because, I mean, the underside of the board could not be more clear in what it's doing. It is very, very clearly connected in the way that it is. Ay, 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 ay. And we ohmed this out. Pretty sure. What else could be going on here? I mean, if this goes up to here, that doesn't make any sense. That breaks off from there, not sure. That would mean that if I probe this one here, I would be seeing my wave, and I'm not. And I'm not. I'm just not seeing nothing. Unless we're above 3 volts. Okay, yeah, we're above 3 volts. We're like 10 volts for this whole thing. It's just like a solid... It's like a solid 12-volt punch in the face. What's going on here? Hope I didn't damage more of the board with that. Although we didn't see anything heat up. The only heat's coming from down here, and this is where all our wobbles are being made. Yeah, I am genuinely confused. I maybe need to read up on this thing a little bit more. I just don't get why we lose our entire signal right here. Whoa, what was that? Why was that all weird? Is that oxidation? No, it like actually changed. Did I just break something by poking my probe around? I don't think I did. Look at that. That totally killed our signal. Because when I probed down here, I saw things change just a little bit. I don't think we can kill stuff that readily. Let's just like power everybody on again. Turn power off and then back on. And just see what happens there. Oh my god, did I partially kill it by doing that? What did I do? Whoa. That is unique. Okay, so like, okay, this should be high Z. Oh, I set the vertical scale. You're right. You're absolutely right. Okay. Every, like, once in a millennia, the adjustment, or sorry, once in like a millennia, the tip of the probe can potentially make weird stuff happen on your circuit. Yeah, I got it now. That's what did it. Okay, I just forgot. Although it does seem to be a little bit weird, but that's, I guess, further down. We did add cables to everything. That seems to match up a little less than it used to, though. Before it was like right on target. It was the exact same wave. Well, this one should be. Oh, no, there it is. Okay, yeah. It's before the resistor. So we're after the 220 ohm resistor. We're down in the meat of the circuit. But that resistor, I mean, although that carries a signal, specifically we are, oops, hold on. Specifically we are right here. So we're after this capacitor. The resistor is flipped to the other side of the capacitor. And then we have a 2.2K and a cap. Possibly that junction down there. The one thing that I can't figure out is where does it go to the transistor? And it should be something baked into the board, because it worked before. You know, this thing wasn't just always orphaned. So in this pathway, is there somewhere else that we are dropping off our signal? Are we picking up on it somewhere else? This is just, yeah, that's just that error. Well, it's possible that it comes out somewhere else. It just seems like kind of weird that you would do it that way. Seems a little bit weird that you would do it like that. This jumps us out to the front panel. Output connectors. That doesn't make any sense to me, though. Why would you split it up like that? You'd be splitting up the circuit like here and going in a couple different directions. Like this junction here would span the entire board, which seems a little bit odd to me. This junction is already traveling quite a few places, but then it would stand to reason that on one of these devices I would be able to pick that wave up and see it. So maybe I need to hunt a little bit more around these. Why is it totally out of focus? Wow. Hunt a little bit more around the filter area in order to find out where our OG signal's coming in. There's some missing components. There's some components that seem to go off in a direction. There's some oscillator stuff over there. It's funny though, they didn't choose this area to go from here on the resistor that's got all the dirt around it to here. Instead, they had to go to the front panel. So they got to go all the way over to here, and then they got to slink their way back and under everybody until we get back over to here. Very strange. But somewhere over here are signals coming in. So I guess I'm just going to start probing a boot. See if I can't find it. And we're going to look for something that matches up to that wave there. Yeah, when it disappears, we're going up to like 12 volts. Huh? When I observe it, it changes. Oh boy, that's not good. That's wibbling a little bit. There's our triangle wave. Sorry, sawtooth wave. Positive, positive. There's that and that. Check over here. I might have to do some more reverse engineering and actually jot down what some of this stuff is, and that way we'll be able to orient ourselves a little bit better. And I can also verify whether or not the filter chip is actually the chip we think it is. Maybe we had a bad impression of what we thought that it could do. Never meet your heroes, chat. The chip isn't what we thought it was. Or it could be. Hopefully it's just harmless in its location. Where are you getting your wave from? Well, I mean, we know it's broken, but if I can find it on here, then maybe we can figure out what's broken. And I gotta watch that Moritz Klein video again about the voltages that are going through something like a diode ladder resistor, alternatively a transistor ladder filter. Because like this is a pretty clear flow. I mean, like our signal comes in here, it would go through and get filtered and then do the transistor stuff, and then it would leave, I don't know, somewhere around here, where it would go into the transconductance amplifier. So it makes sense. It's not seeing it. And those are too big to mess with. I mean, the resistor ladder goes up to positive power, so how frustrating. I really was hoping we could solve this one today, but it looks like we're bogged down in it again. Which, you know, this is fun, poking around this board and discovering all of the little wavy lines that make up an audio processing kind of setup. Very cool, but it gets down to needing to do the work, the nitty-gritty on this thing. And that's when I don't want to bog you guys down in watching me scratch my balls for 25 minutes and writing down little pieces of circuitry. Some of you freaks would be totally into that, though. I gotta figure out what we want to work on tomorrow. Maybe we should do 3D printing tomorrow, so we can have like something going on. What is 0 ohm? What are you doing here? Hey, buddy. Hey, there's 0 ohm. What's that even doing? It's not using it as a jumper. That's the power, the 5.3 volts coming from there. That's right here. 5.3 then goes into everything else. We got a 0 ohm sitting here. That's interesting. I gotta look that up. Yeah, I gotta get to know the circuit a little bit better. I would be into that. All the little writing down of little symbols. I wanted to build this in Fusion, reverse engineer the circuit into Fusion, but it's going to be a pain in the neck to get all these specialized parts in. I may still have to do it though in order to understand what's going on in the circuit, because this may not be, this LM3046 might be misplaced. I might have the wrong part here. I don't think moving the filter back and forth is going to do anything. If I give it a cutoff, we're not looking at the output. We're looking at the internal stuff. And the internal stuff, this ladder filter is not affected by the gate system. That's the next piece. That's what the VCA is doing. So yeah, something funky's going on here, and we'll get to the bottom of it eventually. It's just right now, I'm out of steam. I only got a couple hours of sleep. We've gone all the way through the ringer on this one. We have replaced the front-facing square headers with rear-facing square headers. Believe it or not, front-facing square headers and rear-facing square headers have the same part number. You don't need to get a different part number for them. But they're installed, they're in here, and so our flat cable system to put all of the front panel connectors somewhere else works perfect. And all the traces are relatively viewable on this board. It's just that for some reason, we just can't seem to find our wibbling, waving line. What happened to this? Dunno. There's still broken stuff. I was hoping that conductance amplifier would be the thing that breaks. And the ladder filter doesn't strike me as being all that fragile. It's a bunch of pretty robust devices. So, Acid Labs definitely copied this circuit very well. And that's part of why, you know, what they did here is they were like, this sounds like a 303. We, you know, updated the design of the 303 to use modern parts. And I guess that modern part is that 5 transistors in a trench coat. And, you know, made it into a modular synthesizer. And so they did exactly what they said on the tin. We're finding a lot of the circuit elements to be extraordinarily similar. I think maybe our wave splits and goes to some other locations or something. It may even be coming from up here. So maybe I need to get a a bit of a trace on this and figure out who's connected where, because it seems to drop off the face of the Earth. And inexplicably, it drops off the face of the Earth right around where we think it should be going into the system of transistor filters. So I'm just not sure. I'm just not sure. There should be instructions for calibrations in the manual for the module. No, there's not. No, sorry, Wonky, I missed that message. There are not. The what is it? The Acid Labs don't have, because you can't even get to these from outside, and you would use the tune here in order to tune it. You'd use this tune in order to tune the frequency, not the sort of initial adjustment tune. This is a little bit more complicated, and it is something that I'll be able to figure out. But okay, so I'm lost. I don't know where my schematic is going. I don't know where that waveform is going to. I know it goes to the front panel, but I think it may branch off somewhere in that, and maybe they'll pick up on it somewhere else. It's a strange way to do things, but if you really need to get your signal to the other side of the board, maybe they decided that it was easier to jump up to the other board than back down. Either way, I need to pee, and I need to get out of here, and I'll try to get good sleep tonight, because if we're going to come back tomorrow, we're going to work on this more. I'm going to have to do like napkin circuit diagramming or something of that nature in order to figure out where our wave is going. We're going to chase this down. I don't mean to like fully focus on this thing. I'd like to get to things like burn the subs, but I really was hoping to close the book on this, and it won't close. The book just is like a magnet. It just won't let me do anything with it. But thank you guys. Thank you guys for hanging out with me for this. This has been sort of a chill stream, chill soldering stream. Nobody subscribed today. I need to hit reload. I don't think anybody subbed today. I think there was one. Wasn't there one? No, nobody subbed. That's okay. All right, I'll see you guys later. In the meantime, I guess, let's see. Is anybody on? Uwo's lab doesn't go on when I end because it's like the end of the workday. That Twitch TVO bother. Yeah, hey, I hope somebody learned something. Mater, Lawrence, there's a lot of people on right now. The list is full. Can I? Oh, I need a full screen to pop it out. Niano Cat, you didn't have to do that. Thank you. Niano Cat subbed, and that's 10 months. Dude, thank you, Niano Cat. Madam, you subbed. I'm in introvert sub mode. Ah, that's okay. I appreciate you guys doing the introvert subs. I know what that's like. Queen Ella's doing Grand Theft Auto. IQ Workshop is on. Other than that, it's all the big boys. All right, I'm gonna leave you guys to go where you want. We won't do a raid today, although I really should figure that out at some point. But we're not done. We're going to come back to this. I'm going to study up on my circuits, maybe. I need to do an upload tonight. Otherwise, oh, Tube Time is on too? Yeah, check out Tube Time if you guys want. I should give GoNad the ability to shout people out. Yeah, so I'll be back tomorrow. We're going to be working on this kind of stuff again, because I'm trying to get Dave's module repaired. Until then, I'll do an upload. I'll be around. You can catch me on Discord. Here's end. That didn't work. Here's the end card. I'm ending the stream. Here's the end card. Yeah, we'll have to figure that. We'll figure that one out in the near future. I'll give you guys the ability to shout out. I might as well just mod GoNad too while we're at it. I know he's not going to blow up my channel the first chance he gets. Flatulent Gonard. Bonk. I think that'll do it. I don't know. Oh no, that's the, wait, slash. There we go. I gave moderator privileges to, wait a minute, that's the wrong name. No, I'm just kidding, it's fine. All right, anyway, I'm going to get the hell out of here. I'll see you guys later.